Sorry, I'm going to wear my glasses on my nose like my grandpa because I can't read my notes without them and I can't see you with them. Aging sucks. Hi, everybody. Welcome to CentOS Connect at Flock to Fedora. This is the second time we've had a CentOS Connect with the rebranding. Previously, we ran CentOS Dojos, and we went through kind of a rebranding process, right? We got a new logo and a new event name, and we've tried to really focus on connecting people, right, with the name from different projects within the whole enterprise Linux ecosystem and then across all of our SIGs. And so it's really good, you know, in that respect to be here at Flock this time to connect with Fedora, which is obviously a very important sister project, you know, for CentOS Stream. For CentOS in general, we wouldn't really be able to exist without the work of Fedora. So we're really happy to be at Flock this year. We had planned, we were kind of looking at trying to do 3 per year, with the big one starting off the year in Europe at FOSDEM, and then 2 more. But events this year got weird. So this is our second one of the year and our last one of 2023. But we will, I guess I haven't booked a room yet, so I can't say we will, but we are planning to once again be back at FOSDEM on a day before FOSDEM event. So if you're planning on FOSDEM, if you're not planning on FOSDEM, maybe you should plan on FOSDEM. But if you are planning, you know, pencil that in to join us the Friday before FOSDEM. FOSDEM Saturday, Sunday, right, I think? And then, so the Friday before FOSDEM we're planning to put that together. So anyway, I just want to remind everybody, obviously it was in Justin's opening of the code of conduct that we're all bound by here. And you know, we're also at a Fedora conference, and friendship is one of the 4 foundations of Fedora. So, you know, let's all be friendly to each other and have an excellent event. And in the immortal words of Bill and Ted, be excellent to each other. We have a lot of good talks today. We've got some talks about CentOS Stream. We've got some talks about the work in our SIGs, about the work that happens in EPEL, which is technically a Fedora project, but we love them anyway. And also, you know, some of the other projects, Rocky's talking later, so some of the other projects kind of in the EL ecosystem. So a wide variety of talks I'm excited to hear today. Oh, and also there is the panel tomorrow, which kind of, it's listed as being in this track, but we frankly ran out of like time slots to put something in today. So I begged Justin for a slot tomorrow to put that in. So make sure if you're interested to attend that tomorrow. I'm not sure which room that's in, if it's in here or another, or actually that's in the big room, I think, tomorrow. Okay. And let's see, if you're doing the social media stuff, the X or the Mastodon or TikTok or, I don't know, MySpace, make sure you use the social media tags. There's the 2 on your badge, the Flock to Fedora and Flock Ireland, but also if you're here in this room, please use the CentOS Connect hashtag so that we can see all of your beautiful toots, I guess. And we have Fedora badges for anyone who does badges. There's a badge for this Flock event, and there's a QR code for it somewhere around here as well as throughout the entire venue. Mm-hmm. No, that one. Oh. And then, well, that's the other one. And then we have one that is for CentOS Connect. So if you are here in this room, you can have a CentOS Connect badge. It is the same badge that we used for the one in FOSDEM. We'll do 1 Connect badge per year. If you attend any CentOS Connect, you get it. So if you already got it in FOSDEM, it's not a new badge. But if you didn't, enjoy your totally uncopyable pixels, I guess. And then just a note to the speakers, whoever's here, we do have 25-minute time slots. This includes time for questions. So, you know your talk and how much time it's going to take. You know, if you want to have time for questions, please fit that into your 25 minutes so that we can have our 5 minutes to change over. Sometimes it can be tricky with, you know, laptop changes and stuff to do it in 5 minutes. And with that, I guess actually, Who do I have here? I have a few minutes that I'll kill a little time first. Who do we have here that's speaking today? We can do like really quick pitches, yeah? Like just like a really quick, what's your talk and why should people stay in this room and not give up their seat and hear it? So where's our mic? Well, let's pass it around and quick pitches. Yeah. Raise your hand for speakers.
All right. Hey, my name is Adam. I work on the CentOS Stream engineering team, and I'll be talking about how CentOS Stream works, about how it relates to CentOS projects, CentOS SIGs, and I'll show you everything in the build systems and stuff, how things flow. So that'll be interesting maybe to learn about. 11:30.
Yeah, hi everyone. My name is Brian. I'm coming from the KubeVirt upstream project, and I'll be telling you how we build our CI system on top of CentOS Stream, and how we use it, and what we think of it. Next one.
Okay, Alternative Images SIG. Get your alternative images here. KDE, that's right after this. KDE and EPEL, what are we currently at? What's the future for that? And state of EPEL with Carl, so you don't get tired of my voice. Because he has, listen to this voice. Say something.
You don't want me to talk much. I'm hungover.
Even hungover, he has a better voice than me. State of EPEL, that's the last, I believe we're the last,
That's the closing
last
talk, yeah.
thing. So stay around for the whole end. It's always good. Our graphs look better than Matt's because they're correct.
Hi, I'm Davide. I'll be talking about the work we've been doing in the CentOS Hyperscale SIG to enable CentOS Stream deployments in large-scale environments.
Hi, I'm Eric Curtin. I'm going to give an update on everything going on in our automotive SIG. So we develop a CentOS Stream-based distribution that's designed to run in vehicles, basically. So all the goings on in that SIG, I guess.
Hi, I'm Sharif from Rocky Linux, and my talk will be about secureboot and how distribution can achieve to be more secure, a little bit slightly secure, using secureboot.
Awesome, thanks. I think that's all of the speakers that are in the room, at least. That's most of our speakers. So with that, I suppose we'll turn it over. I'll have the pleasure here of introducing for the first of 3 times Troy Dawson, who this time is going to talk about the Alternative Images SIG.
Thank you very much. Thank you. Alternative Images SIG, let's talk about it. The goal of the Alternative Images is to create alternative images. CentOS Stream, by default, comes with a netboot image and this 10 gig DVD, and there's no in between. And well, we want variations. So that's what the SIG was set up. We invite all groups to come. The Hyperscale SIG is one of our main things. And whenever we do these things, we have lots of goals. We're not going to go all this. It's been 1 year since I've announced this anyway, it's been a year since we announced it. This is a SIG that's going to take a long time setting up. We had to get up the infrastructure. Of course, we had to set up the SIG. We had to investigate what kind of images are we doing. We looked at lives, install plus live, just plain installs, containers, immutable. Out of all those, we sort of tossed out containers because that's what Podman's for. People can make their own containers. So we investigated how to make them, the live CDs, Kiwi, and Image Builder, and to be honest, the only one that ended up working right now is Kiwi. So let's go into doing some of that. This was meant to be a lightning talk, so maybe I'll slow down a little bit. Unless you guys are going to have questions after. But this is getting to the good stuff, what we've actually started doing. We got Kiwi set up in this, the SIG infrastructure, the CBS, CentOS build system. Neil has made some test images. Unfortunately, they are having problems booting, so they're not really what you want. But they are, the infrastructure is almost completely set up. We should be able to push images up to the mirrors, just like RPMs are. Live CD and image builders are not happening. Live CD, just because we don't have Punji, I believe that's the reason. Anyway, it's not happening. Image builder, that's a whole another story, image builder. We also promised we were going to do documentation. The documentation has started. It's still in rough shape, but there is some documentation. One of the things that I've done, when we found out we couldn't do image builder, is I says, hey, here's how to make your own images using the API. I have since found out at this conference that, hey, there might already be a command line, so I don't have to, the documentation might get cleaner. And we're going to tell you how to do Kiwi things using the Kiwi image builder, but that documentation hasn't happened yet. So where's our future line? Kiwi, we're close. We're always like 1 month away from the Kiwi images. That'll be a live image that you can install from, very much like the KDE Spin in Fedora or the workstation in Fedora. We are going to do both KDE and GNOME. We're not going to be, even though I'm KDE, love KDE, we're not going to be selfish, and we're going to do a GNOME one too. And if others want to join once we get the documentation, hey, we can do, I really want to do my ultimate desktop image that has KDE, GNOME, XFCE, all the fun stuff. But that's still many months down the road. Once we get images published, we're going to have sort of some supported ones, the ones that go on the mirrors. We will have those refreshed at least quarterly so that we don't have old images just sitting around. And we, as people come to us and get things going, we'll figure out their consistent things. Documentation, I just said about one, but we're going to have more how-tos. Wow, I'm not talking slow enough. I'm supposed to start just 2 minutes ago. Okay, we're going to have more how-tos. We're going to have better build your old images. Once I started working with Image Builder, I sort of found that this is sort of cool. I hate the web interface. Well, it's not bad, but you can do so much more going through using the APIs and stuff. So we're going to have more templates for the Image Builder. That's it. So I meant this to be a lightning talk. I didn't mean it to be 15 minutes. Do we have questions for this? Or I can talk really slow. Good, we have one.
As the person who also does a lot of this,
Oh, good.
so as the person who also does a lot of the images for the Rocky project, I'd love to talk about how we can collaborate and work on the different goals that we have, and also the similar goals that we have, because our kickstarts that we use to build our images are based on the CentOS ones. So there's the natural evolution there for the history of that. The other side of it is, what do you think of the current landscape as you were talking about all of the different options for building images? There's a lot of tools that have been developed by Red Hat and others and are sort of in interesting states, I guess is the best way to put that. I'm thinking like Image Factory, which is what Rocky is currently using and based off of to build. You mentioned Kiwi. There's a bunch of other solutions as well. So I guess what are your thoughts on the building landscape as it exists right now?
I would love to have more than Kiwi. Not that Kiwi is bad. If we can get it into the thing, the one thing that's limiting us is this CBS, the CentOS SIG build infrastructure. We would really like our images to be built in that, or possibly Fedora, but Fedora sort of doesn't want us. So that's why we're in this room. But if we can get it to work on the SIG infrastructure, we would love it. Yeah, because I believe Image Builder did come up. I put Live CD, but I believe Image Builder did come up. Oh, yeah, sorry, I'm taking this. Somebody told me every once in a while, don't say what just comes to your mind. But OpenSUSE has some really good tools too. So, yeah, there's if we can get it there, I would love to get it. So the automotive is also trying to do things. Theirs is going to be a little different, and we haven't quite figured out how would we get that in there too, which is probably why they haven't really been with us, because we don't know how to build their images on this SIG infrastructure. Anyway, that's the thing. We'd love more than one way. Kiwi's the only one that currently is fitting. Any other questions? Brian, back there.
I've got sort of a philosophical question for you, Troy.
Okay.
Like when you have like a large release engineering operation and you're building a bunch of images for people, you're kind of making decisions that you think are on behalf of what the users might want or something like that. What do you think would make the user folks more comfortable generating their own images or dealing with their own blueprints rather than having them pre-generated?
That's sort of why I was documenting the image builder things. I don't have to repeat the question because you said it into the mic. One of the ways I think users would be more comfortable doing it is by doing their own configs. Maybe starting with a kickstart, but doing their own configs. If we can make it easy for them, like I said, we as the Kiwi group, not Kiwi group, the people that are currently active in the SIG, we're going to set up some initial kickstarts and stuff like that, but we would love for other users to come, and if it is something that we can, auto-generate, we're going to get scripts doing things so that like I said, once a quarter, just automatically redo their image. We don't want somebody to just drop it in our lap. We'd like them to at least show up every once in a while and say, yeah, this is the right image. But we'd love for the users to make their own kickstarts, make their own templates. So hopefully that makes them comfortable, and if our instructions aren't very good, tell us that they're not very good, and we'll work with them to make them more comfortable. Because I do realize that sometimes what goes on in my head doesn't answer somebody's questions. So my documentation isn't always the best, but I definitely would love, if someone says it's not good, to work with me so that it is good. Any other questions? Thank you for the questions, by the way. And there's Neil, in case you're wondering. He helps with the Kiwi stuff. So any Kiwi questions, go right to him. All right, thank you.
fingers crossed. This has been tried before, so it should be fine. So just that, finger, this, and play. Right.
Some people might come over from other rooms. We have all this set up here. aspects. So I'm just going to say our next speaker up is Adam Shumalik, who's going to talk about RHEL development in public. So thank you. Adam, take it away.
Thank you for the not introduction, because I haven't actually updated my bio, so that would be embarrassing. Hey, my name is Adam. I work for Red Hat, and I work on the CentOS Stream engineering team. Just one thing I want to say, I don't represent Red Hat's view. This is my personal view. I have an engineering role, so this has been mostly on that theme. Actually gave some similar talk last time, and last time I showed images like this, and that showed the situation between CentOS Stream, that we have Fedora, where all the innovation and work happens, and then and basically that's where the next major enterprise, the next version gets developed. And then there was a big jump to RHEL, and then CentOS was rebuilt. And these days, we have 2 more steps. Fedora is still the next major version, and we have now Fedora ELN, which is like a smaller subset with specific build flags to be more representative of what's going to happen. And then we have CentOS Stream, which is RHEL development in public, and that's where the next minor version gets developed. I also had this image. I get more details about like where the sources are, about the size, about the build flags and stuff. And this is actually the first change I want to make. I feel like we really need to think about the CentOS Stream and RHEL sources as one thing, because CentOS Stream is where RHEL gets developed in the open. And that affects what contributions are happening in both places and what the goals are. Fedora, as you know, is a community distro, and the goal is to create a community distribution. Fedora community decides about everything that goes in it. RHEL is an enterprise product, and CentOS Stream is the bits where it's the space where it gets developed. So that might influence what gets in there. But the takeaway is basically they have different contribution model. But anyway, this is a community conference. Why am I talking about an enterprise product? I'm here to just set the stage where CentOS Stream is. It's part of the CentOS project, and it's sort of a weird part because it's basically RHEL. But there's many other things in CentOS project that create a community, like SIGs. We have, for example, the Hyperscale SIG that make it work in big scale environment and are actually nice people to talk to. We got the KMod SIG, Alternative Images SIG, Automotive SIG, ISA SIG. There's like many SIGs, and this is where the community is. This is the CentOS project. They usually build above the operating system or do changes within it, but they don't have to reproduce the whole thing. And if you actually want to do work in the OS and do some innovations and integration, that's Fedora project. That's a great place for that, and that's where bigger changes can be done. So also, you may be heard Bex talking about agency. That's what the CentOS SIGs are, and join a SIG or create one, and make your own things. But this talk is about CentOS Stream. So let's have a look at the flow, how things get done. And because my focus is engineering, you'll get a flow chart. So this is basically how every change happens, and I'll walk you through. So first, what happens with every change? There's a Bugzilla bug, and there's some projects going on to switch this to Jira, but that's for later. So that's where bugs get reported or features get requested, and basically an agreement is made to proceed. Merge request happens, that's in GitLab, that's where the code lands in the repo, that gets mirrored to the internal infrastructure, and then a build gets submitted in the build system. We have 3 stages that you can follow the changes through. When the build succeeds, it lands in the gate tag, and I'll show you in the build system how it looks like. Then there's some gating, which are like a bunch of internal automated tests that happen. It gets to the candidate tag, and then there's a verification step, which is really like Red Hat internal paperwork stuff, and then it gets to pending, and can go to a compose. What's a compose? Compose is like a collection of the RPMs, a certain snapshot at a certain time, which are made into a repo, made into images, OS trees, and anything that you can actually consume. And actually one new thing that's not on the slides is we are building some testing, some release testing. So we take the production compose, test it, and then that gets released into the mirrors. And we push to mirrors, we push to key Oakway for container images, Vagrant, AWS, and all that things. And actually, some of the testing, that's something I want to talk about with you later. And we'll be looking for community to contribute tests and define how this works, but we can talk about that. Okay, so let's see how it works. So this is a Bugzilla bug. It's an old one, but it just illustrates how it works. That's how it started. There was like one particular change, and you could see that on the URL like that. Then a change landed in GitLab, which is, that's the pull request. And by the way, that's where all the sources are. So if you want to browse all the RHELs, basically CentOS Stream sources, go to gitlab.com/redhat/CentOS Stream/RPMs, and everything is there, like all the commits as it's landing during development. And they land like pull requests like this, and then a build gets submitted. This is Koji, this is the build system, and you can see all the build logs and everything in there. And if you scroll down a little bit, there's the tags. So there's candidate, gate, and pending, so it passed all the steps, and it's ready for compose. Actually, one thing that we just added like last week is a pending signed, and there's just an implementation detail where all the signed packages land to make releasing smoother. And when it gets released, not released, composed, this is the composes.stream.centos.org. We have the production composes there, so you can get the latest, and there's the repos and some basic images. And after that, it proceeds to the release, to the mirrors. And that's next to the SIG content. And that's where you can get CentOS Stream, the artifacts. So that was the flow. We basically saw it going from bug, contribution, build, test, verification, compose, and to the release. And with that, let's talk about contributions and how Stream relates to RHEL. And you got a flowchart before, now you get a life cycle diagram like this. This is what RHEL life cycle looks like. This is a RHEL 9. I think it's from product pages or somewhere. You can find it online as well. But basically, every minor release, I think this is like half a year each, new one gets released and it gets supported in various ways for various stages. So there's like the minor release, there's extended update support for some, and then update services for SAP solutions. There's even longer life cycle. So you can see like there's a lot of things happening. But for CentOS Stream, you don't really need to worry about it that much. There's arrows that point where sort of CentOS Stream is. So like this whole thing gets developed in CentOS Stream, so it sort of follows along. You don't really get the sense of the minor releases, so that's not there. What's important to know, that the vast majority of packages in RHEL and therefore in CentOS Stream never change ABI throughout the whole life cycle. And there's a document, the RHEL Application Compatibility Guide, that you can Google and read for more details. And Red Hat takes this very seriously because customers build applications on top of RHEL and they sometimes just want to run it and never change them. So Red Hat doesn't want to break them. Which takes us to the contributions. What you can contribute is bug fixes. They're very easy to do and valuable. If you have a bug fix, feel free to submit it, of course. Just please don't break what customers have guarantees on, and Red Hat needs to decide, or the maintainer needs to decide what goes in, so the maintainer needs to test it and merge it. Another type of contribution is stable updates from upstream. That's usually fine. Stable, that's a flexible word, right? This means that this is in terms of changes in the code base. As RHEL gets older, because it's ABI stable, the upstream gets like way more far from it. So, and packages usually don't rebase. So if there's a stable update from upstream, that's good, but RHEL doesn't tend to pull in drastic changes that much, of course. Which takes us to backported feature, which is an interesting thing where you take one feature from a newer version and do a lot of work to make it work in the old version without breaking it. And that's actually how many updates in RHEL are done. And you're very welcome to, of course, do those too. What we can't do in CentOS Stream is ABI incompatible rebases. That's what I mentioned. There's the RHEL application compatibility guide. So please don't send those because Red Hat would need to reject them, or the maintainer. And then there's a special interesting type about docs and typos and man pages. As I mentioned, there's a lot of process involved with every change. So even like if you change one line somewhere, it goes through a lot of process. So it needs to be maybe stacked together and bundled as one thing. So that these might take longer. Otherwise, if you're a customer, there's a thing in the customer portal that you can report an issue to documentation. So there might be a different channel for that. Okay, so that was about the types of contributions, and I know that contribution to CentOS Stream might not be as easy as maybe to Fedora because of all these constraints, but that's actually why Fedora is very valuable. And if you can, please do your contributions in Fedora and let it flow into Stream rather than making changes in CentOS Stream. Or if you want to change in CentOS Stream, just join a SIG or start a SIG and do your change there. That's also very welcome. And yeah. Okay, so how to do changes. Open bugs in Bugzilla. This is very welcome. If you make it easy for the maintainer to reply or read, that will definitely help. You've seen the life cycle diagram. They have a lot of things to do, and we have like 3 major releases on the fly. So there's a lot of active releases they need to take care of. But so opening bugs, merge requests, please send merge requests, but first please talk to the maintainers in a bug and agree with them that they actually have capacity to merge it before. And if that lands, then you can follow it through the pipeline as we've seen and see all changes land in there. And when they make it through completely, they'll be on compositestream.centos.org for you to use. Okay, let's talk about using CentOS Stream. This will be just like 2 slides. Try features in development, bug report, submit patches before it goes to RHEL. That's what it's meant for. It's a preview of the next minor version of RHEL. So that's one use case. Or if you build on top of RHEL, you can use CentOS Stream as CI. Maybe we'll hear about that in a bit as well. And you can make sure that your bits will work on RHEL in the future. Or use it in the community build system along with the SIGs. Build on top of CentOS Stream in that way. And if something breaks, you can always submit a bug or maybe a merge request and get that fixed, which you couldn't with the CentOS Linux before. And that was it about how it works. And now I want to talk about CentOS Stream 10 a little bit, which is coming very soon. And this is a horrible diagram I made. So it's supposed to represent code change and like a Git change. We have Fedora Rawhide branch in Fedora. We have Fedora ELN, which is basically the same. It's just a subset. And when some Fedora get branched, that's where CentOS Stream will start appearing. Actually, we already have some CentOS Stream 10 sources already in the CentOS Stream dist-git. Don't take this as a final list or anything. Packages will be appearing, disappearing. Like it's in a rough state, but you can see them there. And that will be still syncing changes from Fedora for a bit. Then we cut it off and have only CentOS Stream. From that point, ELN will be like RHEL 11, sorry. And then further in the line, we'll start building RHEL, and it'll just become one of the normal releases. Currently, RHEL 10, CentOS Stream 10 are in the Fedora state, so if you want to land changes, go to Fedora Rawhide and land them there, and there's still time to get those. Otherwise, that was mostly it. That was CentOS Stream, RHEL development in public. Remember that CentOS Stream is just one part of the CentOS project on this invisible slide, and it's mostly about the SIGs that create the community in CentOS, and of course Fedora. That's an entire community project, and these are the spaces that you can join and contribute. Here's some of the links, and that's it from me. Thank you. Any questions? Yeah, Neil.
So So you put question marks for the Fedora version with that little graph showing CentOS Stream 10.
Yeah.
But we're already supposed to know what version of Fedora that branches from, so why the question marks?
Why the question marks? Yeah. Do we know the number, actually?
Yeah, it's 40.
It is, right?
Yeah. So why the question?
It's Fedora 40, but we reserve the right to take changes from other places in the meantime.
There you go.
So because
So
Brian doesn't
for
have
the
a
mic, yeah, it's Fedora 40, but there might be some changes. It might be slightly rough, but
Okay.
yeah, that's it.
So it's like,
Yeah.
sure, okay.
Thanks for the question.
Hi. One thing I wanted to clarify when you're showing your rawhide and ELN and then the branching and all of that process. For ELN, most packages are rebuilt. You're just rebuilding with RHEL flags, and there's very little difference. We kind of discourage doing if Fedora if you try not to do that too often. Kernel though, the ELN kernel is the RHEL 10 CentOS Stream kernel. Even though it's the same distget, it's built completely different. It's built with RHEL configs. It is a RHEL kernel. So if there's something you want to see and you don't have to wait for RHEL to branch this and then suddenly make changes, it can go into ELN now and you have a working kernel that is a RHEL kernel.
Thanks for that. All right, cheers, thanks.
If anybody needs a moment to step, we're gonna stick to schedule because there's people in other rooms. So we'll start the next talk in about 10 minutes. brief telling us about secureboot and Rocky Linux.
Thank you. Everyone. So that's like a small disclaimer. The whole process is still learning process for people who know secure boot. And the more you know that you know nothing, basically. So this will be the agenda, and I promise I'll try to keep it in time so I won't hold people for lunch. So I work as a senior cybersecurity officer in the Irish Centre for High-End Computing here in Ireland. We are a research center that provides high-performance computing services for all research institutes here. We are funded by the government. We are part of the university. I started my Linux and open source journey around the year 2002. Been Linux professional sysadmin for over 18 years now. And then I'm volunteering and a part of the Rocky Linux release engineering team. I'm mainly focusing at the moment for secure boot, SIG HPC, and SIG Alt-Arch, and SIG kernels. And I'm a board member of the RSF and Rocky Linux project, and Peridot. Also, I'm a little bit into ham radio, or tofu radio as I call it, since I don't eat ham. So let's talk a little bit, take a step back about how secure boot started. So the UEFI released a specification, which it used to be called back then EFI version 2, around 2006. And I thank Vincent Zimmer for correcting my information regarding the dates for the history, because there is not too much documentation about how this whole thing started. Then Microsoft started pushing a Windows logo program, or what used to be called the Windows logo program, which required hardware vendors to be able to run Windows 8 to have secure boot enabled. There was some information that's not 100% clear to me. There was discussions that for specific architecture like ARM, you can't disable secure boot, and then they went back and they disabled this feature, so now user can enable or disable secure boot, but there is a lot of back and forth here. There was lots of panic, maybe until like 2015. Lots of the people in the open source and Linux community was saying, okay, basically Microsoft is trying to lock down running Linux in any hardware that has secure boot. Fedora 18, CentOS 7, Ubuntu 12.04 was one of the first that started releasing secure boot and shim. There was a lot of frustration when you have a third-party driver that, like any of the graphics driver that outside of the kernel tree, won't run because you have secure boot, and your option either disable secure boot or build your own kernel or sign your own driver, load your certificates, and we will come to that later. But the current state for how the secure boot community is working is very great. There is lots of collaboration between people from Microsoft, Oracle, OpenSUSE, Red Hat, Debian, Canonical, and there is loads of coordination now between the shim and the grub developers and Microsoft. So there is no more non-visibility of what's coming next regarding to firmware development with the hardware. So what's secure boot? Secure boot basically is a layer that tries to protect you from running malicious code into your operating system, before your operating system. So like the boot kits and so on, which is great. And we will see now how it works. So you have a set of keys that usually ship with your firmware. There is usually one master key, which is called the platform key, which is usually related more to the hardware vendor. And then you have something called kick, that might be one key or multiple keys, which is key exchange keys. Then you have two types of databases, DB and DBX. DB will have what the firmware is allowed to load, and DBX will have what the operating system cannot load. That's in theory, most hardware will be shipped with those sets of keys pre-configured and then installed. And then secure boot and the firmware need to start a chain of trust. The whole chain of trust is based on the public key infrastructure within the firmware. So the platform key will sign whatever kicks that there, the key exchange key. The key exchange key will sign a database that includes a specific certificate that then will sign your first bootloader. Or will sign a database, which is DBX, that will prevent specific hashes and certificates from loading in your firmware. In practical, at the moment, the kick database, for example, within most of laptops that will run Windows will have a Windows certificate. And then the Linux community need to submit a specific first stage bootloader to Microsoft, getting signed and then loaded into your operating system. That key exists in the DB of the firmware, the Microsoft keys. We will also get this into details in a little bit. But don't mix the DB and DBX with the actual shim DB and DBX. So shim is what Linux community and open source community wrote to be able to boot a first stage bootloader on your machine when you have Microsoft keys. For one reason, grub2 is under GPL 3, and it can't be signed unless you will release your signed keys, and Microsoft and other people will not be releasing the actual private part of your public key for the public, because that will defy the whole idea of having a secure boot kind of concept. Then there was another aspect being added, what's called the SPAT, which is Secure Boot Advanced Targeting, which is a metadata that you put on top of your EFI loaders, and will have more information about this software that you are running, like the version, some URL or email, but most importantly is the second column, which is a global version. And that also will allow the EFI and Secure Boot to disable specific loaders or specific version based on their global generation. As you can see here, we have shim version 2, for example. So that's mean that we cannot run anything that says shim version 1. And distros use that to revoke malicious or vulnerable bootloaders that's been already released to be running anymore in your operating system. The DBX and DB within shim introduced as a, a reaction to the grub boot hole bug, where basically there was I think around 8 security bugs in a grub at a certain point, and that require all grub hashes to be added to the DBX within the firmware, which is basically took half of the NVRAM that assigned in the firmware to be able to load or forbid hashes. So shim now has their own DB and DBX. Okay, so why should you use Secure Boot? So security is not a luxury, it's a mandate. You have, as long as there is security you can use, you have to use it. So for end user, it will protect you from bootkits. It will give you control over your, if you bind it to load, and that's happened when organizations basically wipe the firmware or load their own sets of keys inside the firmware to make sure that you can run only a specific EFI that they wrote. Most military will be doing that. They will not leave it with the stock keys. Also, you as a developer, you may not want any kernel to load or any grub to load unless you build it and you compile it, so you can build your own small secure boot infrastructure, and whenever you have your distribution, whatever the distribution is, you can load your kernel, your keys, and you make sure that this laptop will only load your stuff. For distros, we try to make end user life much more easier. Also, it allows us to be able to actually prevent vulnerable EFI and bootloaders to load on the operating system. For example, if now we found out that we had a bug in grub that been released, we can use Secure Boot to disable this grub and tell the users in advance, you need to upgrade the grub because at a certain point this grub will not boot anymore. Okay, so let's talk now about the process of how a distro can achieve Secure Boot. And that's a little bit of a mix between technical and non-technical. Most of the obstacles in Secure Boot are actually non-technical. So they are all more about process governance and your procedures to actually be able to sign and build Secure Boot. So we will talk about the technical part first. So in high level, you need to have a FIPS 140-2 level 2 operation environment, and there is a little bit of discussion regarding the operation environment, because some will tell you enough to have the keys are stored in an HSM that is FIPS 140-2 level 2 certified. But we prefer if the whole environment is FIPS certified. Then you need to generate your own distro keys, as we've talked. Some distros will prefer to go with extended validity certificates other than building their own CA and having a self-signed CA. Then you get your shim, and you put your CA within this shim. Then you split your certificates and put them within your kernel, grub, FWD, and shim as well again, and whatever other EFI binaries you are going to load, compile and sign your packages without shim. Now, you need to get this shim signed by Microsoft. Otherwise, that's great. It will boot in your machine if you actually loaded your shim CA into your firmware, as we were talking about. Microsoft has some requirements to do that, which is basically, first of all, you need to be registered with their partner program for hardware portal, I think. You need to get your organization to be vetted and have an EV certificate. You need to provide your security contacts. You need to fill a shim review form, or it's a GitHub issue, basically. And you go through the shim review process. So the shim review process are being reviewed by a community of Linux developers. Mainly, they are shim and grub developers that volunteer their time to do that. They are from most distros, Red Hat, Oracle, OpenSUSE, and I don't want to forget anybody else, Debian, Canonical. And they check actually all your code regarding shim. They only sign grub at the moment, so they make sure that your grub is hardened correctly. They require you to have specific fixes for certain CVEs in grub. They make sure that your kernel have a specific configuration like lockdown, and that your kernel also has specific patches for CVEs fixes. And then once your shim review is accepted, you get your shim, and of course it needs to be reproducible. So the shim review will try to rebuild again your shim, and they need to get again the same hashes. Usually you provide a container file and maybe a side repo where you actually was using the packages and the tool sets that you used to compile the shim for. Once your shim is accepted, you go back to Microsoft portal and you combine your multiple shim, if you are signing for multiple architecture, into a single cap file, sign that cap file with your EV certificate that Microsoft portal has, and submit your shim to Microsoft. Pray and hope that everything will go well, because sometimes things stuck in the pipeline at the Microsoft portal. So Microsoft will do lots of processing on the binaries. They will compare, that make sure that everything is running fine. Once everything is good, they may ask you a questionnaire, like fill some questions and answer some questions about why you are submitting shim and this is other than the shim review. After maybe a couple of weeks, you will get a signed binary from Microsoft, which is basically a shim, including your distro CA, which is signed by Microsoft key, that the public part of the certificate within the firmware of the laptop or your PC or whatever. You get this shim binary and you drop it into your RBM, start running a lot of tests, make sure you are not gonna break everybody's laptops and nobody will boot. Once you are happy, you can release. So the chain will be, firmware will verify your shim has your certificate or your CA, you have few certificate from this CA that actually did sign your kernel grub and FWD, whatever other EFI binaries you have, everything will boot. So far so good, but then come the kernel modules. So the kernel modules is not and considered a part of the secure boot. So if you have your kernel in lockdown mode, you won't be able to load any kernel modules unless they are signed by the kernel. But the only part that's signed from your kernel for secure boot is actually the kernel image, but not the initramfs or initrd, which is why now there is some discussion within the systemd community for the UKI where you need to combine a kernel boot command with the initramfs and the kernel image and have one with a stub and have this signed for secure boot. The keys, most of the distros like CentOS and Red Hat and others, they use ephemeral keys while they are building the kernels. So your kernel modules are, your spec file basically generating a key, then they are signing the module, and then these keys are gone. But your kernel knows that these keys, know the keys through something called a mock in your machine, which is a machine owner key database that shim generates, including some of the kernel keys that you have while you are building your distro. Then you release. That's so far so good. So the approach, how we did it for Rocky, I sadly kind of volunteered myself to do this. I said, okay, I'm going to volunteer to look into secureboot, which was a great journey, and I'm still learning a lot of things. Then come the most complicated part, which is finding actually a FIPS 140-2 level 2 environment. Most of the major cloud providers, they do have an HSM service that is FIPS 140-2 level 2 or level even 3 certified. However, there is no operation environment that can connect to this HSM that is FIPS 140-2 level 2 certified, and that caused lots of issues. And we ended up actually finding a data center where they are FIPS certified, and we had hardware there, and this is how it is. But again, as I was chatting with some people who actually wrote some of these requirements, and they were saying, okay, mostly we just require the keys to be in the FIPS environment, not the whole build environment, but there is no confirmation about this. Based on the documentation that's issued from Microsoft, the whole environment needs to be FIPS certified. And we needed to start installing those, releasing those packages with secureboot, so we went only with a single certificate for kernel grub and FWD. Everything went fine. We submitted shim review for 8.5. I mean, we submitted before 8.5. However, until we got the whole process done, 8.5 being released, and we finally released 8.5 with a signed shim from Microsoft. We had to go on to another iteration, and we released a newer shim because our shim was based on 15.4 plus some cherry pick get patches that the shim review committee required us to have before the shim reviewing was being released. Now we have shim 15.6 signed. There is shim 15.7 already released, and I think within a few weeks we will have a new shim released soon. So we went into two phases. First phase, we went with a single certificate, as I was mentioning. We were using a YubiKey FIPS 140-2 level 2 HSM module. And we were using PE sign in server and client mode to be able to sign the rest of the binaries, the kernel and grub and so on. So PE sign will talk to the UBHSM, get the keys and sign the binaries. But now we move to phase 2, which is, this is actually the current that we have at the moment. We still have the self-signed CA for shim. We start separating the kernel, grub, and FWD certificates. So now basically we have multiple certificate per package. And we move to use UPHSM, UPHSM FIPS 140-2 level 2, which will allow us to be able to use more even certificates or key slots within the HSM module. And we move to use PE sign tools, SP sign tools. And so far that works fine and give us less headache. And now we have more modular of a kind of a networked HSM that we can use even for signing other packages within the secure boot ecosystem that we are building. Okay, so what's next? At the moment in the RESF, we are talking about joining the UEFI forums as contributors. We are thinking and talking about signing other kernels from Rocky SIG kernels, which will include kernel mainline, kernel LTS with some configuration patches we are building. We are looking into the PowerPC and the Z-System secure boot because those are a little bit more complex and they don't do the traditional EFI kind of concept of loading packages. Also, we're looking at the ARM64. We never submitted an ARM64 shim to Microsoft because Microsoft has different requirement for that, but we are going to look into that and submitting this. And the aim is to help the SIG Alt Arch to have secure boot running on most of the system of chip embedded hardware if it's applicable. And also we are looking at the UKI from System Boot, which is, as I mentioned, the combined kernel with init, RAM, FS, and command line, and System Boot, which is a boot manager. And we need to automate. At the moment, there is not too much automation happening within this when this signed. which is good and bad because you kind of need to confirm that you are doing things right, but that doesn't mean that it can't be automated and have more monitoring. In secure boot ecosystem, there is a SPAT support being pushed to the kernel patches at the moment, and the NX support for kernel patches. The NX support is a little bit tricky because Microsoft from last November require any shim submit to have an NX support. And there is no NX support at the moment in the kernel, and they won't sign any shim unless it's NX supported. So I know that Debian is the only, or they code the last cycle of releasing shim, and that's NX supported. And I know that they will be backported the NX patches to their Debian kernels. For the SPAT, still under review by the kernel developers. So that's to recap. Any questions? Yes. Okay.
Is SPAT real?
Okay. Is SPAT real? It is there. As far as I know, there are still patches need to go in to be able to actually do the revocation correctly, or as far as I know. I'm not 100%, but I know that at the moment you can run things below your SPAT version. Okay. But that should be fixed, I hope, within the next release of shim, which is very interesting because I don't exactly know what the history behind having the SPAT if you can actually use the shim, DB and DBX, because with DBX you can just prevent all your hashes. So the idea also of the governance here that we were talking about, that you need to keep logs of everything they are doing. Everything needs to be logged. All your binary hashes need to be stored, so you can actually make it easier for you to revoke. But what I know is that the SPAT and the DB and DBX was a reaction to the boot hole. But yeah. Any more questions?
This may be a dumb question, but you were talking about the fact that kernel modules need to be signed if your kernel is signed, obviously, if you're wanting to use them. Yeah. Is there a way to with the secure boot Rocky Linux release, is there a way to do either to sign your own, if you have out-of-tree kernel modules, is there a way to load them up without having to go through all of this?
Yes, there is a way. So that's why the kernel module is a little bit confusing, because the kernel module is not actually a secure boot feature, but if you have kernel lockdown on some patches, it will be a secure boot feature, and kernel modules will not load if you have secure boot enabled. And even, as far as I remember, there was some things that you need to make sure that the kernel can check that the bootloader actually honors secure boot. However, there is a ways that you can load another certificate, so you can sign out of tree modules if you want, and then load them into your mock tree, but then you will have to do that. The way that this works is some distros will have a specific key that they will be certificate loaded, but it's not used unless it's need to be used for signing an out-of-tree kernel if they really, really audit it and they want to run in their distros. Otherwise, it's up to the user. User can just build their own kernel and then load this key, load the certificate into their mock database into the machine, and then it will load. I hope this answers your questions. Yep. Thank you. Thank you. Yes.
I guess this is kind of a me catching up question. From what I understand, the shim was originally developed so that you could actually use secure boot with Linux, regardless that it wasn't the whole thing signed at the time.
Okay.
Is that correct?
I'm not 100%
I guess
sure
that's why it's called a shim. But
so,
no.
Yeah.
So that you don't have to submit kernel images.
Yeah.
To Microsoft.
Exactly, not the whole thing. Just the shim.
Yeah.
And so what does, I mean, going through that process, what did you, what does, I mean, it must be like all the open source operating systems are just doing shims, and what does Microsoft, is there anything like is there any feedback from them about that, or they're just like, yeah, whatever, like they don't care?
It's not that they don't care. So the idea of shim that as Neil and I think David? Yeah, David mentioned that so you don't need to push your kernels and so on, but also you could have just pushed your grub to be signed by Microsoft, but that can't be happen because the grub 2 license will allow will force Microsoft to release the keys, and you don't want to do that. That's why the shim existed in the first place, to be able to submit something to Microsoft so they can sign, and then other Linux distro can load that. At the moment, as far as I know, the shim has hard code only to load grub 2, and most of the shim reviews will only advise you that at the moment we are only reviewing your shim or your submission if you are only loading grub 2 kind of concept. So that's what the main idea of the shim, that you have something simple enough that submit to Microsoft, very easily audited, and then Microsoft can sign it, and then you can take the chain from there, loading your own certificate and your own key. Also, the same way as when you are loading the keys for, like when you put your CA within your shim, you can actually utilize the DB feature of shim and have multiple certificates there. And there was a lot of discussion in the community, okay, why just we don't have one shim that has all distros key, sorry? Yeah, there was this discussion to have this kind of concept. Also, there is now a side tools that's running within shim that actually, I think they just changed the name recently. It used to be called CertMule, which basically, if we are in Rocky and another distro that you want to load your own, only the kernel modules or only the kernel images signed by you, you can give us your certificate and we will sign this CertMule and then it will be loaded. It's kind of similar to DBDBX, but the issue with DBDBX that every time we need to update this DBDBX, we need to send it back to Microsoft to be signed. So that's why there is this CertMule tool exists. However, it's not very used yet. So, yeah. Any more questions?
I don't have questions. So are there any more questions?
Going once, going twice. Okay, thank you so much.
Thanks, Sri. So lunch is served or will be served in 3 minutes. The lunchroom is on this floor just down the hallway. And we will return here or whatever track you want to be in an hour at 1:30. If you come back here, we're going to get a Hyperscale SIG update, followed by an Automotive SIG update. So thank you, and I'll see you at lunch. look at the schedule, there is 3 talk slots followed by the break, and we only have 2 of them scheduled in this room.
Are these working?
So we have kind of a bonus break, or you can go to one of the other tracks.
Or in our case, we're going to other talks that we have to give.
I guess we'll improv handoff on
You
this
guys
one.
are ready?
Yeah, we will.
Yeah. I believe we are.
And David and Neil will give a Hyperscale SIG update.
Cool. Hi. Hello, everyone. My name is Davide.
And I'm Neil.
We'll be talking about what the Hyperscale SIG has been doing lately. I've given various versions of this talk over the years, so hopefully this is not too boring if you've been to one of the previous ones.
But hey, we have a logo now. That's
We do have a logo, yes. These are slightly less boring than they usually are. So here's the agenda for today. We will do a quick recap on what the SIG is. We will talk about deliverables and what recent work we've been doing, and we'll close with a few notes about what's coming down the pipe. Do you want to do the intro, Neil?
Yeah, sure. So the CentOS Hyperscale SIG is primarily focused around the CentOS Stream. Our goal is to be able to support, enable people to collaborate to bring what they're doing to support large-scale deployments of CentOS throughout to the community and to be able to help everyone kind of benefit from those kinds of things. And key to that is being able to have this community-centric, cross-company, cross-stakeholder collaboration on packages and testing, because in any real organization that's going to run any kind of Linux at scale, whether it's for desktop servers, cloud, whatever, you're going to make your own packages, and you're probably going to be either replacing some stuff or shipping some stuff or updating some stuff or whatever. And in a lot of places, they wind up just doing it internally and then never sharing it with anyone. We want to bring that more into the open and to help people build a good community of practice around this kind of stuff, and maybe even upstream some stuff to make it better for all the other people. And open to anybody who's really wanting to do this kind of stuff, whether it's desktop, server, cloud, weird thingamajig here or something. Yeah, we're open to it.
Yeah, and to be clear, even if this is primarily targeting large-scale environments, you don't have to work at a company to contribute to the SIG. It is really open to anyone, so if you find this kind of work interesting, or if you think what you would like to do would be a good fit for the SIG, by all means, feel free to reach out and get involved. So the SIG was established in January 2021. We started with 6 founding members from various companies. We've now grown to 30 members, which has been quite fun. And to be clear, this isn't necessarily 30 members that are like actively doing things all the time, because people have various interests. Some people will join just to work on a specific thing, and they will keep like working on that. But generally speaking, I would say we have a core group of people that is fairly active, and then there's a wider group of people that kind of come and go or will join for specific activities. We hang out on IRC on CentOS Hyperscale. The room is also based on Matrix. You're welcome to join at any time. Most of us are in the US, so you might get interactive replies if you hit us up on US time, but people generally keep an eye on the channel. There are formal meetings every 2 weeks, also on IRC, on the CentOS meetings channel, which you're also welcome to join if you would like. And for the last year or so, we've also done monthly video hangouts. This was something that started during the pandemic, and it proved very nice both to actually have some kind of face-to-face connection, especially when we couldn't meet each other at conferences. But it's also useful, and this ended up being a mix of social time and like occasionally working through problems or just shit posting. It's fun.
Lots of that.
It's an open Zoom meeting, so anybody's welcome to join. We've also started doing actual in-person meetups now that we can travel again. We did our first meetup in Boston at DEF CONF US last year, and we did our second meetup at Connect earlier at FOSDEM. I wanted to do a meetup at this event, but we couldn't get it scheduled in time. But hopefully we will do another one this year, later in the year at some point.
Somewhere, maybe.
We will see.
So this is really just, more detail about the things that David and I just said. You want to check out, we try to document all the things that we're doing, and we have a back catalog of talks and things like that, as well as our ticket tracker that shows what kind of stuff we're working on, what we're thinking about, things of that nature. Feel free to check all of them out. Lots more detail.
We also publish activity reports every 3 months, I believe. Whenever Sean emails me that I'm due for an activity report.
Which he did just before this event
We are
started.
due for another one that will come out after this conference at some point, but you can find the previous ones linked there. They're all published on the CentOS blog as well. Okay, let's talk about scope. Generally speaking, the SIG is focused on, as I said, enabling large-scale deployments. This happens on various stages and various layers, but The main things that we try to do is, first of all, faster moving package backports. So there are sets of packages that we would like to be able to maintain at a faster pace compared to what's in stock CentOS Stream. And because these are packages that are part of core CentOS Stream, they aren't the kind of thing we could maintain in EPEL. So it makes sense to do this kind of work in a SIG. One example here is systemd that we will talk about in a little bit. The other large bucket of changes we maintain in the SIG is policy and configuration alternative and changes. So packages that are shipped in the distribution that have opinionated default settings that don't necessarily match what would be a good fit for this kind of environments. So we ship packages that have alternative settings here, but with the idea that they are still drop-in compatible with the stock distribution one. They just provide extended abilities and extended opportunities. The SIG is also a good space for doing large-scale testing of features. Generally speaking, in some cases, you're able to test changes just by touching one package, but there are some things that involve the distribution overall. So it is useful to have a place where this can be applied and it can be tested in a production environment. And we will have an example of this later as well. Finally, we produce a kernel build as part of the SIG, and we also produce live DVD images. Okay, let's talk about package backports. Package backports are delivered in the Hyperscale repo that we maintain on a stock CentOS Stream system. You can DNF install CentOS release Hyperscale. That will give you access to the repo. As I said, these are meant as drop-in replacement for stock CentOS packages. So if you're running a stock system and you install this, it should behave the same as your previous stock system. And if it doesn't, that's a bug, and you should let us know. These packages are built against EPEL, and they require EPEL, because frankly, a modern system isn't terribly useful without EPEL. We only target x86 and ARM, because those are the only architectures we can actually test on. But if somebody's really passionate about, say, Power or S390, you are welcome to join us and maintain them. There is a long list of packages I am not going to put here, because it would be very boring. But those are the last ones that, from looking at the build tag, came up recently. In general, these tend to be either packages where the version in Stream is too old to be useful for a specific use case, so it's a backport from Fedora, or a specific patch that is missing that will take a while to get upstreamed into Stream properly, so we'll maintain it in the SIG until it's updated in Stream. And same for the updates, by the way. Oftentimes, these then get rebased in Stream, and we can drop them. Or is packages that we follow the upstream very closely and want to maintain them. Two major items that we are working on lately are OpenSSH and QEMU. OpenSSH is driven primarily by Meta, where we have an internal build on OpenSSH with a fairly extensive patch set that we'll be slowly working with the OpenSSH upstream community to get open sourced and ideally merged into OpenSSH proper. So we're gonna try and get this maintained as part of Hyperscale. There are builds of these already out, but they're not in the repo because frankly I don't trust them to be usable. But if you want to play with them, the sources are out there and the patch set is there. Likewise for QEMU, we have a few members in the SIG that are interested in having an up-to-date QEMU. Ideally an up-to-date QEMU in EPEL, because QEMU would actually be a good fit for EPEL, but also I think there's room for doing SIG work here. So we're hopeful that we'll be able to provide QEMU and potentially an extended virtualization stack as part of the SIG in the future.
Right, so as part of what we do, we try to make sure that whatever packages we're either backporting, modifying, forking, whatever, that we can keep track of what's going on. So if you're involved in Fedora, you're probably familiar with release monitoring and the automated notifications for when new versions of software is out. So we implemented a variation of this that actually takes two feeds. It takes release monitoring for upstream stuff, but it also takes information from CentOS Stream core to see whether, when stuff gets updated there, so that if we have a package that is actually forked from CentOS Stream, we can do rebases and stuff like that, as well as being able to track the things that we track from mainline from Fedora, for example, like as we're going to mention later with systemd, where we track further along. We can make sure that we're caught up with that and keeping up to date. We don't yet do the rebuild stuff. That's something that we're kind of trying to figure out how to do. It's a complicated mess of interactions with all the infrastructure to do it properly, but it's a goal that we want to have because we want to reduce, because like if with the package set that we have and a bunch of different things, a lot of it is very mechanical after we get the initial package made, and so we'd like to be able to reduce the busy work and make it easier for us to do more high value stuff.
Yeah, and if you're in a SIG that maintains packages, you can run the same tooling if you would like. It's published on that repo. It's relatively straightforward to deploy on OpenShift.
Yeah.
Or really any other deploying environment where you can deploy containers. So let's talk about systemd. As I mentioned, we have a branch of systemd that we track as part of Hyperscale. The release version currently is 2.5.2. I think we had 2.5.3 in progress, but we'll probably just do 2.5.4 at this point because that just came out upstream. We have builds for Stream 8 and Stream 9. This generally tracks the latest-ish systemd and is built with the defaults of the latest-ish systemd in Fedora. Among other things, this means that it ships with secureboot 2 by default. And I expect at some point you will actually drop support for secureboot 1 when that ends up happening upstream in systemd. It also ships with a plethora of extensive daemons that systemd provides that aren't shipped in CentOS Stream by default. So it ships with UMD, it ships with networkd, with resolved. UMD, if you're running the stock kernel from Stream, you will need to run it with PSI, which I believe is not enabled by default in 8, and you have to boot with PSI equal 1 or something like that. I think we have PSI 9 enabled
in
by
9
default.
installed there, and UMD is actually provided in CentOS Stream Core now for 9 as well. It's just not installed by default.
Yeah.
But,
and I don't think we have the weights in the, stock one. We do have the weights now?
Yeah, they
oh,
have
nice.
the weight. We added that upstream.
Excellent.
So only networkd and resolved is also upstream, also turned off by default. But networkd is the specific one we add on top, and then there's a bunch of stuff from Meta and the systemd community backported down into to make it better for our use cases.
Yeah, we also, so an example recently was the journal stuff, for example, where there was a lot of work coming from Meta where folks were working on improving the journal upstream, and these were changes that we were able to test in production by leveraging the SIG, and then we were able to get them landed into systemd upstream, and then they became available as release builds. This build also supports SE Linux, although as far as I know, none of us actually run SE Linux in production that are running this environment. Yes, well, you do, that's right. If you're passionate about SE Linux, we could really use more people to keep an eye on the SE Linux stuff here, because it's hard. But generally, these are just backports of the SE Linux policy onto from Fedora in a module just to make it work. And if you're interested about features in systemd specifically, you can reference just the news file from upstream, which is very comprehensive. The way we actually do is that we have a repo on Pagure that tracks the actual systemd upstream repo that we use to stage patches. That's the one that we make releases from. This usually tracks systemd stable, not systemd. We then have another repository for RHEL that we used to have this on Pagure, but we moved it to GitLab so we could leverage the GitLab pipelines CI. These has both scripts that developers use to do the general work, but it's also where the CI is maintained. The way the CI works is that we do daily rebuilds of our packages against the latest systemd Git head. So the idea is that every day we get signal on whether has there been any change in systemd upstream that would break on stream in our environment, so we can do something about it. Sometimes it's a bug on our side, sometimes it's something that needs to be fixed in systemd, sometimes a little bit of both. This has been very useful at Meta internally specifically. Oh, I work for Meta, by the way, in case it wasn't clear. But it's also useful in general. Neil does not work for Meta. Neil works for Reddit. But this has been useful in general. Long term, we would actually like to have a bit more of extensive testing here, so we could do things like, say, spin up a VM or a cloud instance and run a battery of tests, potentially run the test suite. We're not quite there yet. The how to work with systemd is documented fairly well, so you can reference the contributors guide if you're interested in doing work there. All right, you want to do this one?
Yeah, sure. Right. So some time ago, some lovely folks from Intel came by and said, "Hey, we want to try to do cool things with our CPUs, and there's nowhere to do it." Yeah, we were okay with doing it. Let's go for it. And so we worked with Intel to create a space for them that included, things like a zlib backport with some enhancements that they've been working on, some glibc stuff. They're ABI and API compatible. Last I heard, actually, that some of that's going to move to the ISA SIG, and some of that is going to move into CentOS Stream Core finally, and some of that's going to be completely thrown out and replaced with a Fedora change at some point, because there's some things that are targeted that we could go into Fedora to then bring into the next RHEL or something like that. So there's some stuff going on there, but yeah.
Yeah, you can reference the blog post for more information. This is actually a pretty good example, I think, of the kind of change that can be staged in the SIG and then can provide a place to prove that it's actually useful and valuable, and then it can get upstream in all the proper places. And long term, we can sunset the changes in the SIG itself.
It's also one of those examples of where something can start out in our SIG and then fork out into their own SIG if it makes sense and they have some kind of sustaining energy for it. So.
Oh yeah, as I mentioned, we target 8 and 9 concurrently. Most of the new development, I would say, happens on 9 and then is backported on 8. I think most of our production environments these days are on 9. I expect at some point we will sunset, well, we will definitely sunset 8 by the EOL, but I expect as we get closer to the EOL, work that goes on 8 will start dwindling quite a bit. As part of the SIG, we actually did quite a few contributions to Stream itself. I'm not going to read off all of these, and this is not a comprehensive list. But these are some examples of things that we worked on in Stream itself. These generally led to either contributions on GitLab to CentOS Stream proper, or working with the developers in Stream to land the corresponding change in the distribution. And I did not list all of the rebases, because that would be
a very long list.
It's far too boring. On the testing side, as I mentioned before, the SIG also provides an avenue for doing large-scale testing. So the example we have here is the copy on write change we've been working for quite a few years now. And the idea behind this change, that you can read all of it on the Fedora wiki, is that it's that change to the packaging stack, so RPM, DNF, and that ecosystem, to leverage ButterFS and leverage copy on write in a way that can make package installs more efficient. And this isn't just patching RPM, it is a fairly extensive change that involves multiple components. So it's kind of difficult to test by just installing a few packages. So what we did in the SIG is that we provide a repo called experimental that has all of the packages needed for this change, that you can install the release package there and then do the DNF upgrade, and that will give you the whole stack, and it will let you leverage this feature. This is what we run in production at Meta, by the way, because we actually run this stuff and it works fairly well. But it both provides a way for people to play with it and test it, and it's also a nice playing ground that allows the change to evolve. And there's been quite a lot of discussion upstream in RPM on the best way to integrate this change, and it has, the form of it has changed quite a bit, and I've linked the various MRs, because the various PRs, so I think it's a fairly interesting thing to look at if you're interested in the history of the change. But having it out there made it very easy to point people to, here's a place where this actually works that you can test, that you can play with.
Yeah, and so for the kernel, we, on top of the stuff that we're doing with the user space stuff, I, in the SIG, actually make a kernel that enables other features. Primarily, we do, right now, I think, a simple DRM enabled across the board for basic graphics, and we have ButterFS support. We build for CentOS Stream 9 and 8 based on the CentOS Stream 9 kernel tree, and it's available in the experimental repo, and it's really like a complement to the other stuff that we're doing in the user space. And as part of doing this particular work, we actually did a bunch of contribution work to CentOS Stream 9 upstream, and I wound up being the guinea pig for figuring out how the hell to handle upstream contributions in the CentOS Stream 9 kernel. And part of that, I chronicled my experiences and kind of wrote for our SIG a cheat sheet of like how to correctly contribute fixes to the CentOS Stream 9 kernel. And in addition to that work, the SIG helps with Kmod ButterFS for the Kmod SIG to make sure that it stays working and that they can ship it for RHEL as a separate kernel module. This is a
I can do this one. On the user space side, there's a few changes that take care of the user space side for ButterFS. So we have a backport of ButterFS progs, because stock RHEL doesn't ship ButterFS, so they don't ship the user space for it either, so CentOS Stream doesn't either. So we ship ButterFS progs and we ship com sides. We also ship the storage stack and installer in the distribution where ButterFS support is restored. So this can be used for building Anaconda effectively and building images with ButterFS. We also ship other kernel user space, so ISTL, for example. There's a few other things, I think, in the same vein. That list is not comprehensive. Finally, we ship a modified build of Kpatch. Kpatch is shipped in the distribution, but the version that is shipped in RHEL and in CentOS Stream doesn't include the actually useful bit of Kpatch, which is the part of making kernel patches. Because I believe it's meant for, you get kernel patches from Red Hat and you can apply them. We ship Kpatch with the build side, so you can make your own kernel patches if you want. And we also ship support for Clang PGO optimization, which is something that Meta has been working on for the past couple of years. Because we use Clang extensively for kernel builds internally. I am not going to talk about PGO because it's a complicated topic, but if you're interested in this, there was a long talk at Plumbers last year, I believe, that covered this. So you might find that interesting. In addition to packages, we also have container images. Container images are great because they give you a way to quickly play and test the system. These are built from scratch on OpenShift. You can find the repo there. These aren't based on existing Stream container images. They are bare images built from nothing. The reason for this is because the CentOS Stream container images were originally based on UBI, and that made it very complicated to layer changes on top. These are hosted on Quay, and you can use them with that Podman one-liner if you want to play with it. These are minimal container images, so they're fairly suitable for doing work on top if you would like to do so.
I like using them for CI/CD stuff because EPEL's also pre-enabled and activated in it.
Yep.
So on top of this, like with the container stuff, along with the kernel and the RPM cow, that kind of builds up to the live media spins that we've been working on. So currently we have two CentOS Stream 8 spins, the GNOME and KDE Plasma, that were built with kickstarts using live CD tools. These include basically their whole suite of stuff except for the Intel repo, and allows us to give people a complete experience of what our entire stack looks like and how it performs. You can download it and check it out. We've been, for the past, year and a half or so, been plugging away at getting CentOS Stream 9 stuff done, using Kiwi descriptions, getting a whole bunch of infrastructural work done to support it within CBS, because for CentOS Stream 8, I was doing it on my laptop. And I was uploading everything by hand, and it sucked, and it was very manual, and sometimes I screwed up, and that was not good. So for CentOS Stream 9, we're trying to automate and simplify the process so anyone can do this anywhere. And because of the work that we're doing for this, we actually we helped essentially spin up the Alternative Image SIG, and we've been using our expertise to help them get started to start providing images as well.
Yeah, the idea is for eventually all of the image building work to converge within the Alt Images SIG, so that becomes kind of a service that is available for other SIGs that would like to build images, so we don't have to reinvent the wheel every time. Coming up in the future, as I mentioned, there is more work to do around image builds. There's the work we talked about, Kimu. We have a long-standing goal of putting together a way to do transactional updates using Btrfs. We would also like to have cloud images at some point for Hyperscale. These are both things that we would like to have in the future but aren't quite there yet. Here's a few links that you can reference. I will upload these and attach them to SCAD so you can get a copy of the slides afterwards so you don't have to remember this. And that's all we had. Do we have time for questions?
2 minutes.
Okay. Are there any questions? Zbyszek.
So this is not a question for Neil, it's a question for you. Mm-hmm. You mentioned that you contribute stuff to Stream, and there's this issue that was even mentioned today during the keynote, that Red Hat only wants stuff that is useful for RHEL. Does this create a problem in practice for you?
Yes. This has been a long-standing source of tension, I would say. I think in general things are trending in the right direction and are getting better, but I think there's a lot of variance depending on who maintains specific components within Stream and within RHEL on whether your contribution will be accepted or will be timely reviewed or not. So there's areas of the distribution where it's very easy to get changes, where it's very easy to have a conversation on, hey, this component should really be rebased. And we can get that done quickly. There's other areas where this can take a while. It can take several conversations. It can take getting somebody offline on a meeting to actually discuss it, and sometimes it's just not a good fit. And sometimes you do end up having to do this downstream because for whatever reason, it just doesn't work well. So I think that's something that we are trying to figure out overall. I would say that compared to trying to do this back in the day when we were with CentOS 7, CentOS Linux 7, this is far better than it ever used to be. And just the fact of having everything in the GitLab repo where you can submit MRs directly there, you don't have to rely on like attaching patches to Bugzilla and hoping for somebody to see them. That's already been a big improvement. But yes, I agree that this is something that we overall need to do better at. Any other questions? Thank you.
Okay. We'll have a changeover. I was wrong. I misread the schedule. Eric's up next.
Did we steal somebody's slot?
Well, I only looked at start times and not
This is yours.
Yes,
got the long time.
Oh, did we steal Eric's slot? Or?
No,
Oh.
no, we probably should have swapped them based on the other ones. But
Yeah. All right.
you're actually we have 5 minutes of changeover scheduled into the schedule.
Okay. It's like, if we didn't have that, it would be very difficult.
There would be something for bullets if you just saw the whole thing.
So like, David and I are doing another talk.
Oh, yeah?
Yes.
That's like one.
Because then I do Fedora Saki with them, and then I do the other day that I do Fedora Saki right after that. Cool. Where am I going to go backwards?
I'm going to try and sprint that aside in case I always remember any move shape from that.
It'd be nice if the bunch could actually run the presentation on the Mac. Yeah.
Automotive SIG update. Yes.
Am I good to start early? Yeah?
I think you can start early, because we're not gonna get, the other rooms are in the middle of a 1 hour talk, so nobody's gonna be coming over.
Cool. Yeah, so this is a general update of all sorts of goings on in the CentOS Automotive SIG. So for those of you who don't know me, I'm Eric Curtin. I'm a software engineer at Red Hat. I work mainly on automotive stuff. And I wanted to give special thanks to Sandro because I found this beautiful slide deck lying around, and I asked him could I use it and extend it and embellish it, and he said yeah. So thanks for helping me create the slide deck. So yeah, our SIG is still relatively young. I think it's about 2 years old now. So just to give a description what it's all about, this is an example of an open hardware vehicle from a company called Open Motors. It's a very bare bones framework. It comes with no software, no electronics. It just has the minimal requirements for building a vehicle, so you can make your bespoke custom changes on top to make your vehicle more individualistic. So I kind of think of CentOS Automotive Stream Distribution and RHEL, Red Hat and Vehicle Operating System. It's kind of the software version of this, so building up your software in a vehicle starts from the operating system. So CentOS Automotive Stream Distribution, for short, sometimes we call it AutoSD, enables you to do this. So just before I describe this slide specifically, our model is very simple. It's very similar to the CentOS Stream RHEL model, where CentOS Automotive Stream Distribution is based on CentOS Stream, and we just have additional automotive repos that generally add extra automotive specific packages, except in the case of the kernel, we actually replace the kernel. And same goes for Red Hat in Vehicle Operating System. That's based on RHEL, and we add additional packages for automotive. So because we're based on CentOS Stream and RHEL, the usual workflows for contributing to Fedora, EPEL, CentOS Stream all apply, of course. But for an automotive-specific change, we also have one other route for contributing. So this would be what's called in this slide the CentOS Automotive SIG repos. So if you can contribute your change there, it'll make its way to CentOS Automotive Stream Distribution, and which will eventually make its way to Red Hat in Vehicle Operating System. And then we have this kind of continuous certification and testing framework. So if anything pops up, the change is made into the repo, and it propagates through the pipeline again. So yeah, we receive all kinds of contributions from hardware vendors doing hardware enablement, from automotive vendors like General Motors or something like that, for feature requests and whatnot. Sometimes software developers just want to add certain libraries that maybe aren't in CentOS Stream as the base. And we also work with other partners like Sophie and Eclipse SDV. So sometimes we include reference implementations for the standards that come out of those groups. And oh yeah, so this is one of the few packages we actually replaced. So we have our own automotive kernel. This is like 99% the same, 99% the kernel that goes into CentOS Stream. The key difference is we use the real-time Linux patch set. So basically the scheduler for this type of kernel that focuses on determinism and low latency. And sometimes I use this analogy to describe the whole real-time Linux thing for people that aren't familiar with. Let's say you're a driver of a vehicle and you hit the brake pedal. You would probably like the brakes to react quickly. And within a certain time frame. So this is kind of what real-time Linux is all about, and in these kind of safety critical domains, it's often used. So yeah, there's a focus on functional safety. There's specific certifications that we aspire to achieve for the operating system, and this is all about basically reducing the risk factor, ensuring every function is carried out as prescribed. I've heard this analogy from a couple of people in automotive in the past. So obviously we can't ensure that bad things never happen, but like the analogy often used, if I give you a gun and you shoot yourself in the foot, that actually worked as designed. You just used it in a poor way. So it's a lot of that is going down to things like reading the man pages. Do the man pages say what actually happens when you actually call this function and execute the code? So it's all that sort of thing. And of course, there's performance standards. We aim actually to be the first continuously certified Linux platform for road vehicles. And this effort is kind of essential, to be honest, to the safety of automotive Linux distributions. We actually pump a lot of effort into this area. Another difference from, say, vanilla CentOS Stream is we use OS3 kind of as our immutability solution. A bunch of Red Hat-based operating systems use this. Just to name three is RHEL for Edge, RHEL CoreOS, and CentOS Stream CoreOS, which, if I remember correctly, was announced at the last CentOS Connect. So what does OS3 provide? It has a lot of desirable qualities that are suitable for automotive. So OS3 gives you atomic upgrades. So say if you get a power cut in the middle of an upgrade or whatever, there's no such thing as a partially applied upgrade or whatnot. And there's also kind of a tool that complements OS3 called Greenboot. So once you do an update or install an extra package, when you reboot, there'll be health checks, and you can mark a boot as successful or healthy or bad or fail, and in that case, you would obviously roll back. So the atomic upgrades feature is desirable. I started calling what OS3 does directory-based A/B updates, because I've talked to a partner in the past and they've often said it's not A/B. It doesn't do A/B switching because you don't require A and B partitions, and that's not actually true. We just do A/B updates in a different way. It's more directory-based rather than partition-based. So yeah, we applied Delta upgrades because OS3 is basically like a Git repo for our file system. So you just apply the diff on top every time you do an upgrade. So it provides immutability. So like the file system is read-only, so you can't really change it that easily. Although I will say if you're a developer, there are some developer tools that can give you write access. There was an interesting talk earlier about secureboot, a kind of somewhat related project to OS3 at the moment is something Alexander Larson and Giuseppe are working on called ComposeFS. And basically what ComposeFS kind of does, it kind of extends the chain of trust further down to the file system. So you can like detect malicious changes or bugs that cause data corruption or whatnot. And something that we don't include in Automotive Stream distribution, but I think it's an interesting advancement at the moment in the whole OS3 ecosystem, is there's a tool being developed called Bootsy, and what Bootsy is, it's using OS3 containers as a transport and delivery mechanisms. So you're booting into a container, but it's not a container per se. You're just using the protocol basically. So that's kind of cool because it's kind of consolidating our transport and delivery mechanisms. But yeah, this is kind of a future thing. Oh yeah, going into more detail about ComposeFS, I left a link to a talk Alexander did there in the GitHub repo. But yeah, there's ongoing upstreaming in the Linux kernel, and we intend on backporting that to, I suppose I should say CentOS Stream, because that's where it actually lands. But eventually propagates to RHEL, and since we're based on those operating systems, excuse me, we will be one of the users of this. So yeah, as I said, it detects, it verifies the file system is the way it's supposed to be. Like in case your hard disk failed or something and there was disk corruption, it detects that kind of thing. What else do we have? Oh, this was brought up in an earlier talk as well about how we build images. We do something slightly differently to the other SIGs. So you may have heard of Image Builder before. The core kind of framework that Image Builder used to compose operating systems is called OS Build. So we just use that actually. We're not so interested in the UIs on top, so we just kind of wrap some make files and scripts around OS Build. And basically that's how we build our images. We don't have Anaconda installers or anything like that either, because people don't, well, 99% of people don't install their own automotive operating systems. Yes, yeah, I'm sure there's always the 1%. Oh yeah, this is just another diagram. So we take, oh, I finally had to remember why we put in this slide. One of the differences with CentOS Automotive Stream distribution and Red Hat and Vehicle Operating System is, although we provide sample images for you to play around with and develop on and whatnot, it's actually generally the end customer that does the final build. So they'll take all the CentOS stuff and they'll also add their packages and whatever on top, and they'll actually do the final image build, so then they get their own custom in-vehicle operating system. So yeah. These are some various communities we're involved with. I'm more familiar with some than others, to be honest. The scope of this talk is a little large. but just to give you an idea of some of our partners we work on automotive standards and that kind of thing. Actually, yeah, I wanted to talk a little bit about the difference between CentOS Automotive Stream distribution and Red Hat in-vehicle operating system. And I'm actually going to go back a bunch of slides because there's something I forgot to say. On this slide, actually, there are some packages that only make it as far as CentOS Automotive Stream distribution and don't make it further because there's a distinction between the project and the products. And I'll just give you a simple example of some of those packages. We allow you to install CentOS Automotive Stream distribution on a Raspberry Pi to have a generic ARM environment to kind of play around with things. And we have a bunch of packages that enhance the experience on Raspberry Pi. But those packages will probably not propagate to Red Hat in-vehicle operating system, for example, because Raspberry Pi is not an automotive board. So sometimes there's a difference between like the CentOS Automotive Stream project and community and actually the final product. So that's something I forgot to talk about. Not every package makes it all the way. And this goes, the next group of slides are going to show some slight differences between CentOS Automotive Stream distribution and the final product as well. So what is CentOS Stream distribution made up of? We have a kernel. We have a container runtime and all sorts of container-based tools. We have an OTA framework that delivers security updates and that kind of thing. We provide logging and mechanisms for monitoring and diagnostics, the usual systemd stuff, syslog, and that kind of thing. We have various tools for development. We have a lot of health checking tools for various types of failure detection. We have mixed criticality support. That's kind of like this whole software-defined vehicle approach has gotten very popular, and most of the industry is actually trying to reduce the number of ECUs in a car. So boards now have to satisfy many different roles. So this mixed criticality support is what this is all about, and I'm actually going to briefly describe that in a slide later on. On priority boot up, we've been putting in a lot of effort trying to optimize our boot because there's kind of an expectation in automotive to boot like really quickly. Often people talk about the 2 or 3 or 4 second boot or whatnot for different services. And then there's Red Hat in-vehicle operating system, which obviously has all these neat features, but then it has certain additional things on top. So if you want the certified version, that's Red Hat in-vehicle operating system. And you also get various safety manuals and documentation and that kind of thing. Here's another project that started in the automotive org. It's called HRCHA with an asterisk because it's going through a renaming process. I think it's on its 3rd name now. So hopefully we have the final name next time. It's a multi-node service controller. It's kind of like a new container orchestrator, but it has alternative qualities that are different to traditional container orchestrators. So it aims to be deterministic rather than aim for eventual consistency. It's lightweight. There's a focus on performance. And it's also very simple, and like the lines of code count isn't exactly huge, which makes it easier to certify. I left a link to a blog post, and there was also a recent talk about that at DevConf that goes into more detail. QM is kind of a related tool to HRCHA. This is something else we're working on. it's kind of all about namespacing containers to make sure that they don't interfere with other workloads, because like some workloads in a vehicle are a lot more critical than others. Like, I don't know, the brakes might be more important than Netflix. I don't know, that kind of thing. So it achieves that using various tools like Hairchip, Podman, C groups, namespaces, SE Linux, Podman. And actually, an interesting thing about this QM containerized environment, each container even launches its own instance of systemd. Yeah, so you'll hear a lot about ARM enablement in automotive, because 90% of the SoCs deployed are ARM-based. So it's part of the reason I've worked on some of the Asahi stuff with Davide and Neil. Their talk is soon. But that's our focus. We're also open to alternative architectures in future as the industry evolves. Like we have our eyes on architectures like RISC-V and that kind of thing. So I wouldn't rule out those. We also build everything on x86-64 also, which brings us to our next slide. That wasn't supposed to be the next slide. Which developer tools, yeah, we build and publish everything for x86 also, so people can develop on their laptops, like ThinkPads or whatnot. So we have VMs. You can actually spin up an instance now in AWS. All the various container tools. We even have a container on Quay now, so you can use those for development. As I said, on x86 and ARM. We even have emulators if you need an ARM environment on your Intel-based machine. We actually even produce a Raspberry Pi bare metal image if you want a kind of a physical board to work on that doesn't break the bank. And we have a lot of these artifacts are downloadable at this link. And there actually are further artifacts that you have to build yourself, but so now this slide. These are some of our various publicly announced partnerships. So GM, Qualcomm, Luxoft, and ETAS. Some of them are more related than others, but yeah, it's all part of the wider automotive SIG. What else? Did I skip over anything? No, so yeah, I think I said everything I was supposed to say. These are just some things as an aside. One of the guys I know on the team asked me to spread awareness that the Fedora robotics SIG is kind of being brought back to life. So there's a lot of similarities between the stuff we're working on and the robotics SIG. So that's kind of a SIG that's getting some more attention now. And as we said, actually a huge focus in the automotive SIG is on ARM enablement with various automotive boards. And Davide and Neil are actually doing a talk after this, and it's around the enablement work we've been doing for Apple Silicon. And actually I found that really useful because we talked about the Raspberry Pi in the past. Raspberry Pi it's a €100 board, so it can be a bit slow. So I actually find the Apple Silicon hardware it's very useful if you're looking for a generic ARM development environment for Auto ST or other ARM-based operating systems. These are some of our community contacts. You may have met them before, people in the room, but we have Jeffro, who's our acting chair. He runs monthly meetings, which are quite nice if you want to learn more about the community. They're quite informal. We normally have a decent attendance of 20+ people, so that's a great way to informally just jump in and chat and speak informally about things you're curious about. We have Pingu, who works with Jeffro, And we actually have Leo Rossetti. Leo Rossetti is often our point of contact for the SOFI community and Eclipse software-defined vehicle. Yeah, here's some various links to those monthly meetings I was talking about. Jeff will post most of them on YouTube in the end. We have a GitLab where you'll see all our automotive artifacts. If you can't attend those, if you don't want to attend those monthly meetings and would just like to informally ask questions, I find the matrix is very good, as well as the mailing list. They're all very responsive ways of communicating with the community. Yeah, and that's kind of it, unless there are any questions. Looks like I'm good. Thanks very much, guys. You made my job very easy.
We are giving you a bonus break after all. The other rooms all have a session starting at 2:30, so if you want to check out any other rooms or just have an extra half hour to relax. And we'll be back in here at, what is that, 3:30 for Troy's second talk, KDE and EPEL.
Okay. I'll let the cameraman tell me when to start. Oh, you're good. Oh, I'm good. Okay. Hi, everybody. I'm Troy Dawson. I'm a Fedora KDE SIG member. More specifically, I build the KDE in EPEL. So I build it for, well, RHEL compatibles. Let's start with a bit of history. With RHEL 7, KDE was in RHEL 7, along with Qt, both 3, 4, and 5, but that was KDE 5. With RHEL 8, they ripped it out, and by they, I mean I actually ripped it out. They told me to. I've been a KDE user since I've been using Linux. I tried them, so that's 99. I've been a KDE user, so when I was asked to take it out of RHEL 8, it was mixed feelings. I was sad, but I was excited because I knew then I could take it over in EPEL and do what I wanted with it. So where are we now? So RHEL 8, those of you that are still RHEL 8 users, actually there's a lot of RHEL 8 users, I shouldn't say those of you. We are at Qt 5.15. Those that don't know, Qt 5.15 is going to be the last of the Qt 5 releases. From then on, it's going to be patches. I don't know how long. Right now, we're at 0.9. RHEL 8 isn't expecting any other Qt updates unless they're critical security updates. And for KDE Plasma, RHEL 8 is at version 5.24. We're at 5.24 because I basically can't upgrade anymore. The libraries are so old. All the other, Poplar, GPG-Me, there's like 5 others. We just couldn't get it any further. So right now, that's where we're at, and that's where 8 is going to stay. For 9, that's the more exciting part. 9, currently we're in this transition with RHEL 9.2 that has Qt 5.15.3 and CentOS Stream that has 5.15.9. So in RHEL 9.3, Qt is going to get updated. It's not going to get updated in RHEL 8. Again, that's probably just going to be critical updates for RHEL 8. But with 9, we keep pace with the latest stable Fedora. So we're not grabbing things from Rawhide. Right now we're grabbing things from F28. And what happens is we upgrade them on CentOS Stream. So in this case, EPEL 9 Next. You'll see that they're both 5.27. Because Qt is not going to get updated anymore, Plasma, from what we know, and I wish Neil was here, is staying with 5.27. I don't think it's going to go to 5.28, but anyway, just like Qt, they're just going to keep bumping that number up. But EPEL 9 Next is currently, well, actually it'll be starting next week. I'll be updating from Fedora 38. We go into EPEL Next so that we can stage them when RHEL 9.3 comes out. Everything's already staged. We've got the build dependencies. Everything's tested. And then we can just sort of sync the dist-git repos over to EPEL 9, build them. It's nice and quick and easy, and fewer surprises. There's always a surprise. I'm amazed. There's always a surprise, but it's a lot better than if it wasn't. And this slide says what I just said. 8 staying in the current release. Oh, that's right. If there is a major security release, we will try our best to backport it to 8. If it's unbackportable, we'll deal with that later, but 8 also so we said it was 5.24. 5.24 is an LTS release. So about once a year, I make sure, see if there's another release, and I'll do that. But that's not a major upgrade. It's usually just some bug fixes. RHEL 9, as I said, we're syncing twice a year with each release. The reason we're syncing twice a year instead of 6 months, or once a year, those of you who remember last year, or maybe a year and a half, we said we're doing it once a year. That just wasn't practical. KDE was going too fast, and some of their packages says, you know, we need the previous release to build. So we're doing it twice a year. And we test the updates. It's actually pretty stable and pretty good. That's one of the reasons why I like KDE. Now, this is probably what y'all came for. What are we going to do next? And for 9, it's not going to be too exciting. It's not in this slide. So 9, basically, we're continuing what we're going to do until we can't update anymore. We're going to follow the Qt5. This is the current things, Qt5 versions of Fedora 28. Now, at some point, Fedora is going to go to Qt6. And 9 is going to stay on 5. That is the current plan. If we have time, which we probably will, since everybody could ask a question and we'd still have time. If we have time, I have other thoughts, but the current plan is we will stay with 5. Although Qt6 is in 5, and we will continue to update it. So 10, what are we doing for 10? RHEL 10. RHEL 10 is in our eyesights. RHEL 10 will have Qt6, and it will have KDE Plasma 6. We will not be doing KDE Plasma 5. We don't know how well they would match together anyway. But we will have the Qt 15.x. Basically, we're going to be grabbing that from, RHEL 9. Well, anyway, we're going to keep the latest one because RHEL 9 has to keep being supported by Jan, so RHEL 10 will keep that Qt5 at least as long as RHEL 9 does. But let's go back a little bit. So anyway, yeah. But the main desktop is supposed to be KDE Plasma 6. With 5, you'll look in this thing, and this is actually on, we had a discussion on the KDE SIG, and you'll notice that most of these say should or can and things like this. No firm things. Okay, so just keep that in mind. So if things have to. So most Qt5 packages will go into EPEL 10. I can tell you one that's not, and that's Qt5 Qt Web Engine. That is a pain in the rear. I ain't putting it over there. You shouldn't need it. Qt6 Qt Web Engine, yes, that's great. Don't expect Qt5. But the other basic libraries, as long as they aren't a pain in the rear, will be going into EPEL 10. So if a Qt5 package is no longer supported in Fedora, that package will be updated in EPEL 10 on a best effort manner, which means that it's possible we might drop some Qt5 packages down the road if there are some bad security updates. I'm a great packager, and the KDE SIG is great with things, but I am not the best security update person for Qt5. Packages based on Qt5. There's still quite a few that are Qt5 only. If they can be built with both Qt6 and Qt5, we ask here's the should. They should only be built on Qt6. If you want to, we're not going to force you to not build the Qt5 version. But we're recommending that you build Qt6 only, or have some plan of phasing it to Qt6. If it can only be built on Qt5, go ahead, build it on Qt5, but try to move upstream to get them to do Qt6. I mean, by the time, I know we're planning on working on EPEL 10 soon-ish, but by the time it's actually released, I mean, that's still, what is that? Are we still 2 years out? Okay, it's still 2 years out. Qt6 should have been out for a good long while by the time EPEL 10 is actually released. So try to get them all built on Qt6. Oh, wow. I am... okay, let me do the... Oh, we do have questions. Good.
So, first of all, I realized that I said I was Misha, but I don't know if you knew that I'm that Misha who tried to run your build before it was operational.
Oh, okay. Are you the one that is doing the live?
Sorry?
Are you the one, Misha, are you doing the live image?
No.
Oh, you're the...
I was trying at that time to use RHEL for work.
Okay.
I have still relented from that idea.
Okay.
So I was talking to you at the time extensively, and I tried to install your build. The problem is I did that too early. It wasn't operational, and I couldn't even update to an operational one later.
Yeah.
Without reinstalling RHEL, but at the time a laptop renewal came, and I just went back to Fedora. But this is what I wanted to ask since then.
Okay.
You're doing a great job with KDE, but this sounds like a one-person project. What happens to KDE in EPEL if you are Harbour?
It sounds like a one-person project, but really the KDE SIG, I am the rebuilder. The KDE SIG, and if Neil was here, he does a lot of things. If he gets hit in the bus, me and him shouldn't be on the same bus that gets hit by. But the KDE SIG actually does a lot of work to make sure things build in EPEL, so that I only have to do a rebuild. And there is other people that can do it. I have my scripts. People have my scripts. I am nowadays, okay, the early days of RHEL 8, I was doing a lot of stuff. But then the SIG said, hey, we're going to make sure things build on both RHEL and Fedora. And they've been very good at putting those if statements and anything else. This last one, getting ready for the EPEL 9 Next, I literally had to do one package. I did the test builds on Copper and went, oh, okay. And there was like one package, I did the pull request, and to be honest, it didn't build on Fedora either. So anyway, I found their, so okay.
I have a question too about the process as you described. When you mentioned that you would now want to sync with latest stable Fedora once in half a year.
Yes.
This doesn't jive very well with KDE's approach, like it or not, to their own release cadence, where they have only half a year of a supported release. And then they
Why doesn't that fit? You just said twice a year, and then you said half a year. That's 6 months.
Yeah, for 6 months. So is the idea that you would try to synchronize with Fedora right after it takes up the new stable KDE? And then you...
No, we don't. Right now, I usually, first off, they don't, the stable Fedora. So right now it's Fedora 38. What Fedora does, they will put things in rawhide, and they won't even put it into the next one until it's at least a 0.1. And I won't bring it into the EPEL until it's at least a 0.2.
I see.
So it's a good point, but yeah.
And then you would basically pick up the security updates from Fedora.
Yeah.
So that's why it's one half. Okay, I didn't understand it first, but you kind of want to minimize the time when the system, when the KDE version in RHEL, well, EPEL, is not supported by the KDE project.
Yeah, because we originally said 1 year, and like you said, KDE's doing it every 6 months, and it just wasn't working, so we shifted to every 6 months.
Well, they do have an LTF.
Yeah, but and that's what we stuck 8 on. But we were finding that that's what we tried to do for the year, but then when we tried to jump, it was just easier to do the every 6 months.
Okay, now it makes sense though, because the only time when you're not supported by the official KDE project is between their new release and their point 2. Okay.
Yeah. Yep, because it's, we want the bigger bugs to get shaken out first.
Yes, of course.
But thank you for the questions, those are very good. Yes?
When are you going to submit a change proposal for KDE to be shipped in Fedora Workstation by default?
Okay, the question was, when are you going to put a change proposal to have Fedora KDE shipped in Workstation? Instead of GNOME. No, they are not fighting words. Are any GNOME people watching this?
I'm in the room.
Oh. No, yeah. Yeah, this is not the KDE SIG meeting, this is the EPEL one. No, I don't mind it being a spin. I did push dramatically. I am so grateful for the web redo, because when it has Workstation, here's some alternate things that are coming up. Here's documentation. Here's something else. Oh, at the bottom of the page, below testing and stuff is the KDE spin. It's like, yeah, that's sort of insult.
I know the spins are tracked, like in the count me data. How does default Workstation compare to?
Oh, yeah, we've got the mic. How
does the KDE spin stack up against Workstation just in terms of usage? Have you looked at the count me data?
I can't answer that standing at this podium, not because I don't want to, but for my EPEL talk, I use Matt's things, and it has that.
Oh, okay.
He doesn't ever say that, but I have it on my laptop.
Yeah, I know the data's there. I just haven't looked at it. I'm curious.
I'll tell you in about 20 minutes. I never looked at that because it's on the Fedora graphs. And I could be wrong. Maybe it isn't. Anything else? Oh, I actually almost took up my time. I'm hoping other people show up because I'm supposed to give the next talk with somebody else. They're not in the room. Anything else? We can end a little early if we want. Okay.
We are presently opposite the Asahi Linux thing in the Tivoli room downstairs.
Oh.
That is a 1-hour session, so I am sorry to you. I'm sorry to you because that's where most of the conference is. But I think people will come back in for
the EPEL one.
The EPEL one.
Yep.
Asahi should be over then.
This is how I like perfect.
Okay, great. So we have just got use your laptop set up and then there might still be people who come over from the other rooms, so we'll wait for
Cool. Hi everyone. So my name is Brian Carey, and I'm pretty new here. So I am I work for Red Hat, and I'm the upstream KubeVirt CI maintainer. I'm here today to talk to you about how we build KubeVirt CI with CentOS Stream. So just for some background for anybody that doesn't know, what is KubeVirt? KubeVirt is a virtual machine management add-on for Kubernetes. It allows users to create, run, manage VMs in Kubernetes clusters. It's considered a production-grade hypervisor, and as far as I know, it is the leading virtualization add-on for Kubernetes. So it's the leading way to run VMs in Kubernetes. Last month, we had a very big milestone in that KubeVirt finally reached version 1.0. So that was a big release for us. Testing a project like KubeVirt comes with its challenges as it integrates a large number of different projects and sub-projects. But in KubeVirt proper, our testing can be broken down into two main categories, which is unit tests and our larger E2E tests, so our end-to-end tests. The end-to-end tests actually require running against valid virtual test clusters that we spin up. One of the other aims in the project is that we try to stay as close as possible to the methodology used in the upstream Kubernetes projects, so their testing methodologies upstream. This means that we end up using their kind of ecosystem of tools, like services like Prow, which is basically like a Jenkins for orchestrating CI jobs against Kubernetes clusters. So I can hear you thinking, okay, that all sounds great, but where does CentOS Stream come in? So CentOS Stream is the solid base that we use for our virtual test clusters, which are then scheduled to larger workloads clusters. So these clusters are spun up for our end-to-end testing. The test cluster node images, there's a specific project that we have, a sub-project within the KubeVirt organization called KubeVirt CI, and this project is responsible just for building these cluster providers, as we call them. Overall, these cluster providers, the virtual ones, are based off of CentOS Stream vagrant images. So we basically take the latest CentOS Stream vagrant image continually as much as we can. So the building process, all of this is done through automation, but the general guideline for it is we basically have a Fedora container spin up. This Fedora container has all the tooling required to start up the CentOS Stream vagrant image. And then we have a tool for orchestrating the provisioning of these images. We call this tool, it's written in Go, so it's called Go CLI. This tool basically just orchestrates which scripts are run where, as some scripts are run during provisioning, and some scripts are run at cluster runtime, basically. The provisioning scripts mainly focus on setting up network and storage requirements, any dependencies that we have for installing Kubernetes with kubeadm. So these scripts are all run against the VM at provisioning time. Once these scripts complete successfully, the VM inside the container is then shut down, and we then commit that container image as an image, as a container image. So that image is then committed with the updated VM image inside. So, okay, that's great. We have a node image, but how do we know if what we built is actually a valid Kubernetes cluster? So within the KubeVirt CI repo, we have a number of test lanes that run against these any changes that are pushed into the KubeVirt CI repo as pull requests. So these run a subset of the KubeVirt end-to-end tests, and they also run the suite of Kubernetes conformance tests, so that we know if what we're building is an actual valid Kubernetes cluster based on CentOS Stream. Any merge changes to this KubeVirt CI repo leads to new cluster provider images being published to Quay. So they're always available there. When our automation picks up that there's a new image in Quay, this image is then picked up and a PR is created against KubeVirt proper, so that we can run the full suite of end-to-end tests against this image as well. So we do have some protections there against running against the latest CentOS Stream. But we rarely hit any issues. So this is kind of a picture I drew up. Part of the reason why I wanted to do this talk was to spend some time and draw this up from my own mind. So this is how it looks when it all comes together. So these end-to-end test pods, they're basically scheduled to our worker nodes. The ones here below just reflect the top one. It's the same thing throughout.
Generally, so basically within the end-to-end test pod, we have a podman instance which spins up our node container image that we've just published, and then this node container image in turn starts up the CentOS Stream VM, and then the Kubernetes cluster gets to a running and healthy state following some runtime scripts, and then we basically install KubeVirt against it, and we run our test suite, which basically KubeVirt uses this Virt Launcher pod concept for spinning up VMs inside these Virt Launcher pods. So basically those test VMs that we spin up inside that test suite are running in nested virtualization. The bare metal nodes up until recently were also running CentOS Stream as well in production. Some of the benefits we saw from using CentOS Stream, first of all, it's an extremely stable base, so 99.9% of the time we don't hit any issues. So it's just smooth sailing 99% of the time. It allows us to catch any potential issues earlier than we would have previously using the old CentOS 8 model. So previously the providers were built with CentOS 8, but we've moved to Stream 8 and Stream 9. Over the last year, we've hit a couple of issues, really only a handful of issues. A couple of examples here. So we hit a couple of kernel bugs. We hit an issue with Network Manager and some DHCP clients. And then SE Linux policy changes can trip us up every so often. There are components in KubeVirt that basically require certain privileges, and CentOS Stream can't be aware of that. So then we have to talk between projects to see what is the best way forward in that way. Sometimes we have to make changes on our end. Sometimes CentOS Stream makes changes. So overall, CentOS Stream is a very good target for us for testing, as it really reflects our main downstream product, which it will be OpenShift container native virtualization. So it's very good at reflecting that environment, and it also allows us to catch issues very early. So problems we've hit, I really struggled to come up with any major problems here. I had it on my overview for the talk, so I said I better include it. So issues are very rare, as I said on the previous slide. Sometimes we get blocked with CentOS Stream issues. Well, they're not CentOS Stream issues, but issues that we hit. And that blocks us from delivering new providers. So if a new version of Kubernetes comes out, sometimes we could be blocked from testing against the newest version of Kubernetes because we have some issue back here in CentOS Stream. The second point is just a pet peeve of mine. Because we're always testing against latest, basically we have the latest kernel in CentOS Stream, and then we're running our automation, and the automation fails because the kernel modules aren't there yet. So that's when we hit every so often. Then I have community members coming to me and going, "Why are these lanes failing?" And I'm like, "Just give it 20 minutes and they'll be there." But so this always starts up the conversation within the KubeVirt community, whether we want to pin to a certain version of CentOS Stream or not. In my opinion, we get way too much value from running against the latest in order to pin it, and we do not want to be managing uplifts of CentOS Stream because we will fall behind. So I generally just prefer just to go to latest. Sometimes we'll pin an individual package for a certain period of time just to get around a problem, but that's always a temporary measure. Running off the latest just gives us too much benefits. So yeah, as a bonus content slide, I said I'd show you where to get CentOS Stream VM images for KubeVirt. So if you want to if you have a Kubernetes cluster and you have KubeVirt installed somehow, and you want to run a CentOS Stream VM, we have container disk images that we build and publish in Quay as well. So these container disk images are used for ephemeral VMs normally. They're very handy for CI or any kind of testing that you might be doing. They're basically based off of the CentOS Stream cloud images, so they're loosely wrapped around those. So basically any of your configuration will be cloud init config that you would need for that. Yeah, and the image registry also includes a handy YAML example to get a Stream VM up and running very quickly. I was going to attempt to do a demo on it, but I chickened out towards the end. So yeah, here's just a screenshot of the landing page as a result. As you can see, the YAML is quite brief. It's probably a bit small on the screen there, but you have your cloud init config down here, and you just add your cloud init config, and then you can do whatever you want. That basic example will get something running, but it won't be much use to you. You won't be able to sign into it. You won't be able to get into the VM or anything like that. So you add your SSH keys, your authorized keys, or whatever to that cloud init config. So yeah, just to conclude, KubeVirt loves CentOS Stream really. It's not just, as I alluded to previously, it's not just using KubeVirt CI. It's used all over KubeVirt. So all of our KubeVirt artifacts are built in a CentOS Stream workspace. KubeVirt actually relies on the CentOS Stream virtualization stack. So we actually take libvirt and QEMU from the CentOS Stream 9 repos, and we actually use those and build those into our virtual launcher pods that I mentioned earlier. So they're actually the components that are actually starting up the VMs in the Kubernetes cluster. So that's all Stream 9 virtualization stack. And our production CI workloads cluster was deployed on CentOS Stream to very recently. And unfortunately, the burden of maintaining OS updates and Kubernetes updates on that cluster was too much, so we moved to OpenShift just recently. The updates were on me to do, so it was too much. Yeah, so then just to finish up, just to say thank you to the CentOS community, and if there's any questions.
Talks about the vagrant layer. Was that a decision that you made, or? I'm curious a little bit about the vagrant layer. Was that a traditional decision, or is that something that you chose?
Yeah, it was a long-term decision. It was a decision made a long time ago, and it's been carried forward. The vagrant image gives us kind of a handy user setup and login details into the vagrant image, and we just use those then throughout our automation. So to change it, it would involve a bit. But the vagrant images have been working quite well for us. So.
Awesome. Yeah, it's good to hear from vagrant users for sure. So.
This might be a basic question. I missed the beginning, unfortunately, because I was between rooms. But can you explain to me, like, what's the elevator pitch for KubeVirt? Like, it's you're virtualizing inside virtualization?
No. So the KubeVirt product itself will be, that's only KubeVirt CI, so that's only how we're running our E2E, our end-to-end tests. So that nested virtualization only happens within our test suites. But KubeVirt itself, if for anybody that has large Kubernetes clusters that they want to run VMs alongside pods, for large organizations who might be migrating to a Kubernetes workflow and they have existing VMs, they can easily just take that image and deploy it straight onto their Kubernetes cluster or OpenShift cluster. And then they basically, it helps the transition to that Kubernetes kind of way of working.
So the VMs are basically treated as a container, well, not the word container, but a place that apps go. It's not that the containers are running on top of that VM.
You could run, you could go all the way down, but no, generally the VMs would be, just running inside pods, and they'd be more or less, they'd be kind of like monolithic services they'd be running there.
Okay. And then the other question that I had was, when you're doing nested virtualization in your CI,
Yeah.
is the environmental difference when you're doing that, is that limited in terms of you don't find certain things because it's not quite the same environment?
Not really. There is a performance impact. So there's a slight performance impact. So when we run our test suite on bare metal, it runs a lot faster. But the nested virtualization, there's a small performance impact there. So some of the tests may take longer. So we do have we have a flaky test process that we have to try and identify these tests and make sure that they're kind of fixed to fix those kind of flakes.
And then is it running on OpenQA and Fedora?
No.
Okay.
This is all running on a big, large bare metal workloads cluster that we have.
Okay, thanks.
We have 15 minutes until the next one is scheduled, and we will definitely stick to the schedule because one of our co-presenters is not here. And also, hopefully, we'll pick up people after that Asana Linux talk finishes. So. It's our last talk of the day. If you guys just want to start it whenever you like, we're on time, so.
Alrighty. Welcome, everybody. It's great that, I think this is the last one of the day, and we have such a full room that is great compared to my last talk. Those two of you that were here, that was wonderful. Anyway, I'm Troy Dawson. I am the EPEL Steering Committee Chair.
Howdy, y'all. I'm Carl George. I'm the EPEL team lead in the EPEL sub-team of CPE, the Community Platform Engineering Group inside Red Hat.
Yep. And we're going to give our annual State of EPEL at FedoraCon. As usual, I like starting off with graphs. If those of you heard Matt's things, he says there's two types of things. This one is his thing called Velociraptor. And it's basically the old thing, it's just getting the IP addresses of machines coming in. We don't know anything about them. And it's sort of cool. We've actually broken the 5 million point on this one. You'll see that EPEL 7 is by far the biggest, and it's at 3.5 million. So anyway, this is a fun one. We have all these various points. I'm not going to point them all out. The EPEL 9, you can see the EPEL 9 there. I'll point that one out. It's 165.
Point at the people coming in late. Ha ha. Kidding.
It's okay. So anyway, EPEL 7, still by far our leader. Now, again, these are Velociraptizer. If those of you saw Matt's thing, you know why it's dinosaurs, and he's called them dinosaurs because we don't really know what's happening. These are all done by IP address. We know things like Facebook has several million behind an IP address, and it counts as one.
Last I heard, they changed it to plural, millions.
Millions, okay.
Millions is what we are allowed to say in public.
Okay, with an M or a B? Okay. Now this is Brontosaurus Sapphire. So Brontosaurus Sapphire is with the new, hey, I should have that in the notes. New DNF check, I get this wrong, count me, DNF count me. So these are only for 8 and 9, because 7 didn't have it, but these are more realistic numbers. And as you can see, 8's up here at 2 million, which is pretty good. And 9 is at, it's just at.
Pretty good for 2 million.
I'm not going to, I don't ever show these with Fedora numbers because they get sad.
Yes, Matthew has said several times that the EPEL artifacts are some of the most downloaded artifacts from the Fedora project.
Yeah, but for 9, we're only at 200, basically 250,000. Only, yeah. So let's break those down a little bit more. If you saw Matt's talk, he likes to break them down into ephemeral things that don't last very long. 1 week, 2 to 4 weeks, and 5 to 24. So these are actually trends that we are expecting. I used to go over these a little bit more, but we'll call them enterprise loads. These big 25 plus weeks things are what you expect because people don't usually use them in short loads except for testing. So we expect testing, different testing. People that have a 1 month cycle, some people do that. They completely wipe their machine and load it every month. And then the majority of people. Okay, so here comes the funner things. Last time we showed these, we did not put names here, and people were sad. So I'm putting names here. And this is RHEL 9. Now, notice Rocky's in the lead, but it's at 100K. It's not really that big of a lead. But they still are. And CentOS Stream and Alma are basically tied. They're fighting there for second. RHEL, and there's Oracle. Okay, but this is 9. 9, we sort of expect that is still growing. RHEL's going to grow up because a lot of people don't really put their RHEL on until 3 or 4. Well, actually, we'll see.
show on the next
Yeah.
It's right there.
Okay. Now, this is 8. So this has some really fun things that I thought was interesting. And I didn't even tell Carl these so that he can be surprised. The biggest one I think is interesting is CentOS Linux. Right here, this is where CentOS Linux 8 went end of life. And it was really fun because it went down and then it went right back up to almost 1 million. And then it went down, but if you see in the past almost a year, it's actually leveled off to 600,000.
Yeah. Some little clarity on that. My theory is that this wasn't that those systems went away and people deployed new systems. The way that CountMe works is, or the way that the end of life went, the content got moved, the repo content got moved to the archive, or the vault, sorry. And then at that point, because of the order of the repo files, EPEL stopped getting hit and it would, DNF would abort on that first one that it couldn't reach. And so a lot of people would just switch those to the vault repos to keep using the same systems without updates, and then they would start contacting EPEL again. So I think that dip and then coming right back is just people switching from the live repos that got retired to the vault repos that still existed but just were unmaintained.
Yep, and I totally agree with Carl. And but it looks like at some point, at least some people realized that maybe we should get something a
Yeah,
little more
at least some people
supportive.
realized it was a short-term solution.
Yeah, but not everybody. So it's still in first place, but it's not by as much. Now
At the very end, it dips down again.
It dips down again, and
We'll see if it stays.
Yeah, it's dipped down before. The second place is RHEL and Rocky. They keep changing over and over. That's what it is. And this last one, Alma, finally passed CentOS Stream. I'm a CentOS Stream on the engineering team, so this makes me sad.
Touche.
Touche, yeah. Or Oracle Linux is there, and then Cloud Linux. Matt puts this actually on Cloud Linux. Now, here's the next slide. I then went and found all the distributions that have been checking in. And this is where, for me, it's fun. I'm not going to read
This is where it gets weird.
all 101. So Cloud Linux, which was at the bottom of the last one, is at the top of this one. This is 100,000 to 100 users. There's Cloud Linux. And then looking at this, actually, I'd heard of all of these, but Anolis, I don't even know how to pronounce that.
I think Anolis is my guess.
Anolis. That is a Chinese distribution, so I've looked at it, and it's...
Is that the one that's backed by Alibaba?
It was on the Alibaba website, but it might be like running it on Amazon, you know.
Okay.
I don't know. Like I said, it's all Chinese. Oh, I'm not even sure it's Chinese. I think it's Chinese. Anyway, for those 100, that was the one that stood out to me. For this one, these are the 100 through 5 users. Aren't very good. My favorite one on this is this one, 10 CentOS, or 10 CentOS. So,
I'll note that anyone could just edit your etc.os release file and put any name you want in this data. It's not hard to just come up with fun things. And you'll see that on the next slide with the smaller single-digit stuff.
Yep.
Also, if you have a large fleet, big flips can happen and can lead to all kinds of fun things with strings.
Yes.
Oh, yeah.
You wait for next year.
Yeah.
Why doesn't have Fedora there? 24 Fedora systems.
There is Fedora. Wait, where did Fedora? Oh.
Yeah, you got Fedora Linux, you've got Slez.
Yep, Slez.
Yes.
And Machia.
We do, to be clear, we do not recommend running EPEL on Fedora because it doesn't make sense, because the packages in EPEL should already be in Fedora. So it's a little strange.
Yeah. Now,
There is a conflicts in the EPEL release package, but if they just configure the repo file directly, they can still hit the repos and get counted in these numbers. So I know another slide you had Amazon Linux, which, as I understand it, the last Amazon Linux that wasn't based on Fedora Linux was Amazon Linux 2, which was mostly RHEL 7-ish.
Yeah.
And so people are adding EPEL 8 to that release, even though it's not even close to targeting it, and hoping things work.
and you know, for your Python stuff, sometimes anywhere, it's fun. So to show how really weird this is. So, oh great, now where did it go? Foobar, where's Foobar? Foobar. Foobar Linux has one user, and I thought that was weird because I'd heard of it. And the maintainer actually contacted me this last week. They rebuild EPEL. They rebuild all of EPEL. Very similar to like ELN does Rawhide. And this one thing is a mistake. So they have a lot of users. They rebuild EPEL as a package gets built. They rebuild it.
And just don't want to be counted.
I don't know why. All I know is that's where.
That's the new Red Hat Enterprise Linux that's unreleased.
Which one?
RedOS.
Oh no.
Never heard of it before.
Oh, I remember that one from back in my scientific. That's from China.
I mean, there's an IBM Linux up there too, and who knows what that is. Like I said, anyone can edit your OS release file to say anything and put it in here. It's.
Somebody did, because one's just QHF.
Oh, I actually took a couple out. One of them, somebody had actually accidentally piped something into their thing because it was all these weird things. Anyway, I took a couple of them out. But anyway, those are.
You don't want a fork bomb in your slide?
No. This was just for fun. Don't expect it every year because it was a pain in the rear to make. This is more serious, and it's our maintainers. And we are very grateful for our maintainers, both you here, those of you online, and those of you watching you later. Thank you very much. Over the years, we've gotten more and more. It looks like it's going down, but maintainers fluctuate. EPEL is a volunteer-based community. Even most of our stuff, now granted, Carl is currently getting paid for it, but he was a volunteer way before that. And so we want to thank you people. EPEL 9, we did have a trend going down. So the trend is sort of to have 10 packages per maintainer so that no one person gets overwhelmed. And then Rust came in. And this
Thanks, Fabio, if you're watching.
This EPEL 9 got down to 11, and then all of a sudden, just boom. Yeah. And more sad face, I am no longer number one. That makes me sad. Oh. It's not David.
Fabio?
No, he's like 3. The other Facebook person.
Michelle?
Michelle.
Oh, wow. All right, then.
Michelle is number 1. I'm like number 3 or 4. I'm sad. Not that sad. Actually, I'm excited. I'm glad people.
Yes, obviously. Maintaining a ton of packages yourself is not great.
Well, because I was number 1 for so long, I never wanted to say that. I never wanted to give the top 10. Now I can. So anyway, we are very grateful for our maintainers in EPEL, and on behalf of not just the EPEL committee, but as the users, thank you very much. EPEL 7. I'm going to start with this one and turn it over to you. EPEL 7 will go end of life June 30th, 2024. That's less than a year away. Red Hat recently, due to the large amounts, as you saw the second slide, large amount of 7 people, EPEL RHEL 7 people have made this new extended life thing. And I don't know the 3 or 4 letter acronym, but.
ELS.
ELS.
Extended Life Cycle Support, I believe.
Okay. They made this different thing, but the basic ending of RHEL is happening on the 30th of June, 2024. As an EPEL committee, we did discuss this, and EPEL is going to end on that same time. We will not be trying to extend it.
The end of maintenance phase 2.
Yes. So on June 30th, 2024, EPEL 7 will go into archive. It will no longer be able to be, it will no longer be maintained, and all the things that go with the end-of-life EPEL release. Anything else for EPEL 7? I know I'm hogging the slides or the.
No, there's one point we want to bring up that, as y'all saw on the other charts, EPEL 7 is still the most popular artifacts, but it's also getting the least attention from maintainers. A lot of maintainers, they tend to like the new shiny. They're focused on, hey, I can get all my new stuff added in EPEL 9. It's interesting. They like deploying it and getting all those new features. So just naturally over time, EPEL 7 gets less and less attention, which is partially by design. Similar to RHEL 7, it's in the last part of its life cycle and it's slowing down. It's getting fewer changes. Only the most critical things get fixed now. But because it's still so popular, if you have EPEL 7 packages you depend on, consider getting involved in helping take care of those, because we have a lot of open bugs. We look at what open CVE bugs there still are, because there's no guarantees and it's all volunteer. We just kind of hope that people come along. We look at those from time to time when we can, but we would like help if you're interested.
Yep. Thank you very much. Let's go to 8.
Sure.
I'll let you do that.
Let me talk a little, huh?
Yeah.
So with EPEL 8, we did some interesting stuff. This was the first release where we had CentOS Stream 8, and things got shaken up first a little bit. We knew we wanted EPEL we knew how important it is for people that were using it, and we proposed a new thing called EPEL Next, because we were starting to see that some library changes, if you saw Adam's talk earlier, he talked about the application compatibility guide. So while most things in RHEL don't change very much at all, ABI-wise, there are some things that are on a lower priority on that list that are allowed to change their library SO names and things like that. Think LLVM, Qt, and there's a few other things. When those happen now, they happen in CentOS Stream about 4 to 6 months before they happen in RHEL. It's the change that's coming to RHEL, that's planned for and approved for RHEL. It's not some wild, unexpected thing. We see it happening and we know it's going to be coming, but sometimes, occasionally, that can cause EPEL packages to not install correctly. We saw that as a problem with EPEL 8, and we thought about how we could fix that. So we came up with a thing called EPEL Next, and that allows maintainers to optionally build against CentOS Stream 8 to get their packages compatible. It's not a whole duplication of EPEL, it's just a rebuild of those. I think at the times I've measured it, it was usually less than 1% of packages that had trouble with that due to those changes. So it's just select rebuilds, it's an extra repo. So RHEL 8 users would use just EPEL 8. CentOS Stream 8 users would use EPEL 8 and EPEL 8 Next together. And that's worked pretty good. There's been some, it was good for a first attempt as kind of a bolt-on solution to the problem with how the existing way we did EPEL. I'll get into that. That's starting a thread of what I'm going to talk about on the EPEL 10 slide, so I'm going to, backburner that for a minute. But it worked well enough. The other thing I'll point out is the end-of-life stuff. I know you're about to jump in with that. I saw you.
Yeah. So talking about end of life, CentOS Stream 8 goes end of life same time. Let's just say it's the same time as 7. Basically June 1st of next year. With that, the EPEL Next repo is going away. It really shouldn't affect any non-CentOS Stream people, but we just want you to know that it's going away when CentOS Stream goes away, but it shouldn't really affect you unless you.
Yeah, at that point it won't be necessary anymore.
Yeah.
Because that's the point that RHEL 8 enters its maintenance phase, and a lot fewer things would be changing. There won't be any more minor releases, and there definitely shouldn't be any more library changes for lower, like ACG4 packages, the lower priority ones I mentioned.
Yep. We ready for
Sure.
9?
So, EPEL 9, we had the RHEL 9 launch last year in 2022, and we actually, at one point, we thought that it was for the first time ever we launched EPEL 9 before. It's not exactly correct. We found some old mailing list stuff about how EPEL 7 actually launched with a beta period, so it made things a little confusing, and it was actually a post from Kevin there. So we were kind of describing it somewhat incorrectly depending on how you viewed it. EPEL 7 left its beta period after the RHEL 7 launch. So sort of it was true, but also there was something. So there were packages in EPEL 7 just under the beta label at the RHEL 7 launch. We did some lines on this chart. At the time of the RHEL 9 launch, there was 2,617 source packages in EPEL 9, which was great, just having those available on launch day for RHEL. For RHEL 7, it was a little bit behind that. I think I think you said it took about a month for it to
Yeah,
catch up to that point?
It was released in
That
May.
arbitrary cutoff?
It was released in May, we made it
Yeah.
to in July.
And it was like a month after that that we
Yeah.
removed the beta label from it.
We didn't put that on there because it was just
Yeah,
gonna
real
make it
cramped.
messy.
But it's an interesting little artifact of history. So the big thing to take away is the growth pattern for EPEL 9. You can see it's much steeper than EPEL 8. Another thing I'll point out here is that EPEL 8 actually launched, or rather, RHEL 8 launched with 0 packages in EPEL 8. It got a late start. There's a lot of reasons for that, and if this wasn't a 25-minute talk, I would probably get into those, but if you want to know more about that, come and find me and ask more questions because it's a long story. But we obviously knew that was a problem. We actually got a lot of customer feedback about, I'm not upgrading from RHEL 7 until the packages I need in EPEL are there. I know they're not supported, but I still need them. And that actually helped lead to the creation of the team that I'm the team lead of now, the EPEL team within CPE, to staff that role.
I wonder what they're saying now, that all those packages are in 8 and 9, and they're still on 7.
Nah, they're big enterprises. They take a long time to change stuff. So we hopefully this is a lot more attractive target, so that way when they're looking at their upgrades, they may just skip 8 entirely and go all the way to 9 and just get current. A lot of them won't. They'll still go to 8 first, but we can't control that. So go and go to the next slide. So this is a few logos of things, of notable packages we had in EPEL 9. This is from a while back. I forget when we did this.
This is one at launch time.
This was at launch time?
This was
Okay.
at launch time, that we were saying, look, we have all these at launch time. And now, how many do we have now?
A lot more.
A lot more.
Basically ran out of space for logos.
Yep.
Had to resize a few of them. But yes, there's a lot of cool software there. It's growing a lot, and if you've got your favorite piece of software that's not up there or didn't get highlighted, this isn't everything. I couldn't fit everything on one slide. If you have something that you want to see in EPEL, help get involved and get it added.
Yep. Oh, we're at EPEL 10.
So EPEL 10, here's the good stuff. This is what y'all came here to hear about. So I mentioned on the EPEL Next stuff, I talked about it on the EPEL 8 slide. We also had EPEL Next for 9. It worked as a bolt-on solution to get the problem solved, but we noticed some problems with it. It was unintuitive for users and a little bit unintuitive for maintainers as well. The branches weren't created automatically in Dискit. They had to request them. And some maintainers would be confused about when it was appropriate to request a branch. We saw a pattern of maintainers building in both EPEL and EPEL Next just by default. They thought they needed both when the dependencies of the package involved weren't different between RHEL and CentOS Stream, so there was no need for it. It was unnecessary. So we thought, how could we make this more intuitive? And it's actually something, while I was digging up the EPEL 7 beta stuff and reading about that, I found out that this is an idea that's been thrown out before, talking about having minor releases for EPEL branches. So that's what we thought about doing for EPEL 10. Yeah, so here's a little bit of the history. With EPEL 7, we built, the current state of it, it's built against RHEL 7.9. It has a disk tag in the release field of .el7, and it goes in the repo path of EPEL/7. And then 8, you can see that still this is the current state. EPEL 8 follows the same pattern. EPEL 8 Next is still built against CentOS Stream 8. It gets a disk tag of .el8.next, and it goes in a different repo path. Same thing for 9. And then for 10, for reference, we thought about, well, how does this work? We're talking to Fedora maintainers a lot of time because EPEL maintainers are Fedora maintainers. If you're a Fedora maintainer and you're not involved in EPEL, all you have to do is make the branch, and then you're an EPEL maintainer. Congratulations. It's super easy, barely an inconvenience. So here's how it works in Fedora. Fedora doesn't have minor versions, but with each release, we have the leading branch, Rawhide, that has FC39 disk tag. And that reflects what the content is going to be. And there's a very similar pattern with the minor versions in CentOS Stream. What you see in CentOS Stream 9 right now reflects the content you can expect in RHEL 9.3 that is going to be released in the fall. So I know that similarity there stuck in my head, and I kept thinking about it and wondering how could we build on that and make something that's more intuitive. When things branch from Rawhide to F38, or rather, in the future, whenever F39 branches, the F39 branches will be created, and then the Rawhide branch will get switched to the FC40 disk tag. And they've got their own, repo paths. So go ahead and switch to the next one. This is what we're thinking about for EPEL 10. We'll have a leading branch, EPEL 10, built against CentOS Stream 10, and it'll use a disk tag reflecting the content that it should. Say this will be, at this point in time, will be the RHEL 10 launch, basically. So at that point, CentOS Stream 10 will already be reflecting 10.1 content, so it'll get the corresponding disk tag for that. But it'll still, we're going back and forth on this a little bit, but thinking about just putting it in a bare EPEL 10 path, just because that minor version of the content it's reflecting isn't programmatically determinable inside CentOS Stream itself. So the easiest way is to just think of it as it doesn't have a minor version and make the repo path work the same way. But we can still put it in the disk tag for the migration whenever we actually create a 10.1 repo. At this point in time, RHEL 10.0 will be out, and we'll have EPEL 10.0 branches with the corresponding disk tag and repo path. Oh, that's one thing I forgot to bring up that we did different with EPEL 9, is that, you don't have to change the slide for it.
Okay.
With EPEL 9, we launched it early by
right.
building EPEL 9, not EPEL 9 Next, by building it against CentOS Stream 9 early for about 6 months. That's what let us get all those packages in there early. And then that was a huge boom to the project and getting packages out. And we thought about how could we bring that same success? We did it for 9.0, but we're not doing it for any other minor release of 9. This brings the same concept to every minor release. And then packages, the other part of EPEL Next that's painful, especially for Troy with all his KDE packages, is that whenever he does have to rebuild against, say, a new Qt library, he has to do it in EPEL Next and do all of those updates, and then a few months later, do the same exact thing in EPEL all over again. There's no way to inherit the builds because of the way we designed it as a bolt-on thing. With this, we explicitly want to be able to inherit the builds so that things that you build against CentOS Stream, it'll just populate the next repo path a few months down the road and bring that same benefit that we had with the launch of EPEL 9 to every minor version.
So, for example, for the KDE users, when RHEL 10.2 comes out, you will get your KDE packages that day. As soon as you update to the release, so it says 9.2 or 10.2, you got the KDE things because they were already built into CentOS Stream that was corresponded to 10.2. And I don't have to do anything that week, and you don't have to wait and have your broken. I feel bad, but there's only I can only build them so fast. So anyway.
Go ahead.
No, somebody's calling me.
Yeah.
It's okay. Next slide.
So we're still talking about all the finer points of this EPEL 10 proposal. And if you want to join that discussion, the short URL, red.ht/EPEL 10, that'll take you to the Fedora discourse page discussing it. And there's a few breakout threads from there talking about the finer details about how we're going to implement it. And that's all in flight and in progress. And if it's interesting to you, come help us build it.
Yep.
This is all the plan. It's not just the plan. It's approved by the EPEL steering committee. It's the way we're doing it. We just haven't done it yet. And there's some of the finer details to work out still.
Yep. I just saw the time, so we're going to go to the next one. There is an EPEL survey. We're trying to do annual EPEL surveys. We didn't quite get it in time for this one. Coming soon, look at the EPEL Announce and EPEL Devel.
We'll post about it there, and probably in the next week, I would say, we'll have that survey live and keep it open throughout the month of August, I think. And
It'll be
take the
less
survey if you can.
complicated than last year's.
Yes, we trimmed down the number of questions significantly.
And reworded them. I like this year's. And questions and answers.
In the past, I maintained some packages for Fedora.
Okay.
And in the past, there was an EPEL branch, and then you could just push your changes. And right now, I can't find it, and I have been trying I have been looking for information on how to put these packages on EPEL, and I might be bad at searching.
It's okay. It is actually one of our most common questions. Basically, you have to branch it like you do the other ones. They are not currently automatically branched.
Yeah, the command will be when you're in the checked out repo, you can do fed package, request branch, EPEL 8, EPEL 9, whichever.
Yep, actually, maybe we do have it on, that is, if you go to that URL, it has instructions for Fedora packagers, non-Fedora packagers, and just end users.
And
how to
instead of
request.
typing the whole URL, if you go to docs.fedoraproject.org, there's a rectangle that says EPEL, click on that, and then in the sidebar, there's a package request link right there. It'll be a little easier to navigate to than typing the whole thing.
But yeah, that's our most common question, so don't think that's a silly question.
We don't do it, he mentioned that we don't do it automatically, mainly because we don't always know that it's appropriate for an EPEL package to go in the next branch of EPEL. Sometimes it's because that package got added to RHEL, and by EPEL's rules, it can't be in EPEL if it's in RHEL. Other times, the software might just be, no longer maintained upstream, so it would be a bad idea to add it to another EPEL branch that's going to hypothetically exist for another 10 years. So we leave that up to maintainers. We are thinking about a few things with EPEL 10, obviously changing the branching style to have minor versions, but also there's a thing called ELN extras, which is sort of like, if you're familiar with ELN, how it's sort of like future RHEL, ELN extras is sort of like future EPEL. ELN itself is built, specifically of what the content set that's going into RHEL 10 right now, and then, whatever future major version in the future. ELN extras, anyone can create their own workload there is the term, and that's just the packages you care about to make sure they keep building correctly against ELN. So in theory, it'll help reduce the work and make sure things work correctly when you build it for EPEL 10 in the future. We're talking about ways that we can actually look at those workloads and automatically create EPEL 10 branches for those people that have already expressed the interest, I want to have this working on future RHEL. So we've also talked about just creating branches, and then if people don't need them, just whatever, let them, retire them when they want to, or just let them exist and be ignored. But I think that would be good. Not everyone agrees with me, so I don't think we're going to go that route. I don't think having branches around is that big a deal, but whatever.
Yep.
I don't make decisions unilaterally.
Yeah. Any other questions? We're a little low on time, but we got one more.
It's the end of the day.
Oh, it's the end of the day?
Yeah, you're not cutting into anything.
Oh, okay.
You can EPEL till the cows come home.
Oh, good.
Game night's in an hour, so wrap up.
This might be a slight tangential question.
Go for it. We
What
have,
was the-
we have an hour.
Oh, we have an hour. Cool. I can go for an hour. What was the concept behind the Apple logo, or is that?
I got to rewind my brain back. Okay, if Mo Duffy's here, she helped. We were spitballing all sorts of pictures, and she came up with sort of this one. Oh wait, where's oh, there's our logo. But
Do you want me to explain it?
but the red part is RHEL, the blue handle is Fedora, and then the middle one is like a socket wrench. And we figured we'd have a blue, the same blue as Fedora, because EPEL is in Fedora. That's the closest thing we did, but everybody liked it, so that's what it was.
We couldn't have the centaur, so.
Yeah, the centaur, that one never worked out. That was sort of cool. But yeah, I thank Mo, she, for that one. I could show you the old one and try to explain what that was, but everybody that looked at it had a different definition of what it was.
Any other questions?
Yeah. Okay. Well, oh, we do have one. Oh, okay. Well, thank you all. Again, thank you for our contributors. We really appreciate it. It's a lot of volunteer work. A lot of people are Red Hats and volunteer, and a lot of people are other companies that volunteer. So thank you very much, and we'll talk to you next year.
Logistically, game night is in an hour, so you're free to, go back to your rooms or whatever and freshen up or take a break. There will be food at the game night, but it won't be like a plated dinner. So if you eat light, you'll probably be happy. If you like a really big meal, you might want to